Welcome back to Sleepless Mysteries. High above us, beyond the orbits of the planets, beyond even the pull of our sun, a visitor appeared. On July 1st, 2025, astronomers confirmed something extraordinary: an interstellar comet, 3I Atlas, crossing into our solar system. It was not born here. It did not belong here. It came from another star, another part of the galaxy, a traveler from the unknown. And as it streaked through our skies, it carried with it a silence more unsettling than any roar of thunder, because Atlas does not behave the way a comet should. From the first observations, the puzzle only deepened. Its orbit bent in ways that no gravitational force could fully explain. Its brightness shifted strangely, as though its surface concealed something more than ice and dust. Its very presence seemed to defy the neat equations of science. The more researchers studied, the more their models broke apart. For every explanation offered, a dozen new questions emerged. Atlas became not just an object, but a challenge, a riddle written in the stars, and it is not the first of its kind. Before Atlas, there was Oumuamua in 2017 and Borisov in 2019. Strange visitors from beyond the sun drifting silently into our skies before vanishing forever. Each one stranger than the last. Each one refusing to fit neatly into what we know. If comets are messengers, then what message are they carrying? If they are simply wanderers, why do they move with such mystery? Long before telescopes tracked their paths, the ancients looked up and saw the same. Carvings, scrolls, and chronicles describe fiery disks, wandering stars, and radiant objects that blazed across the heavens. Some were omens of doom, others were promises of change, but always they were signs of something larger, something beyond human control. Were they seeing visitors like Atlas? Did they leave behind prophecies we have yet to understand? Or are we only now beginning to catch up to what they already knew? You don't need the image of Atlas on a screen to feel its presence. You don't need to see the faint glow against the black sky to know it is out there. Just let these words guide you. Close your eyes if you wish. Imagine the vast dark ocean of space, endless and silent as a lone traveler cuts across it, brilliant, unpredictable, unbound. Imagine standing on ancient ground, your ancestors watching the same light blaze above them, their hearts filled with awe and fear. The comet has come before, and it has come again. Before we begin, if you haven't already, subscribe to Sleepless Mysteries so these quiet journeys into the unknown will always find you. Tap the like button if these stories bring you wonder or calm, and if you're still awake, share in the comments where in the world you're listening from and what time it is right now. Now, let the present world fade. The visitor is here, silent and strange, defying the science we trust. And tonight we follow its trail into the mysteries that no answer can satisfy. This is 3I Atlas, why this interstellar visitor defies all science, unsolved mysteries for sleep, and it begins now. The impossible speed of 3I Atlas. When astronomers first detected 3I Atlas, they were quick to note its otherworldly qualities. Here was an object not bound to the sun, slicing through the solar system on a hyperbolic trajectory. But what startled scientists the most was not simply that it came from interstellar space. It was the speed. Its velocity was so extreme that it seemed to defy the limits predicted by celestial mechanics. At first glance, one might assume that any object entering our solar system from the void would be traveling fast, propelled by the gravitational tug of distant stars, and ejected from some faraway planetary system. Yet, 3I Atlas seemed to exceed even those expectations. Its entry velocity clocked in higher than any known comet or asteroid. To many, it appeared to be moving at a speed beyond what gravity alone could account for. The laws of physics tell us that interstellar objects should follow predictable curves, obeying the constraints of Newtonian mechanics. But 3I Atlas did not quite align with those models. Scientists began recalculating its approach, questioning whether gravitational interactions could explain its observed acceleration. Some suggested it might have received a slingshot effect from a massive star before wandering into interstellar space. Others speculated it was ejected violently from a collapsing planetary system. Yet none of these scenarios fully explained its extraordinary speed. The margins of error in observation were small, and the numbers remained consistent. 3I Atlas was faster than it should be. This puzzle led to unsettling questions. Could 3I Atlas have been artificially accelerated? The very idea borders on science fiction, but some astrophysicists entertained the possibility. What if an alien civilization had engineered an object to travel across the cosmos? Its trajectory suggested purposeful motion, an almost deliberate path across interstellar distances. If natural explanations faltered, perhaps artificial propulsion could account for what seemed impossible. One speculative model imagined that 3I Atlas was once part of a larger construct, a fragment propelled outward by mechanisms unknown to earthly science. Another layer of the mystery lies in its endurance. Interstellar space is not a gentle place. Objects traveling through it for millions of years are expected to erode, fragment, or disintegrate. Yet, 3I Atlas arrived intact, as if it had been hurled with enough force to survive countless collisions with cosmic dust and radiation. Its velocity, instead of suggesting age and wear, seemed to imply recent acceleration. Perhaps it had been launched, or launched itself, not so long ago on a galactic timescale. The question that followed was obvious. If this was true, who or what had done the launching? The deeper astronomers looked, the stranger the picture became. High-speed travel through interstellar space should produce specific patterns of erosion or heating, but observations of 3I Atlas revealed inconsistencies. Some images suggested surfaces reflecting light in unnatural ways, flickering brightness as though the object was tumbling. Was this merely the spin of a misshapen rock, or something more deliberate, like a stabilizing maneuver? Mainstream science resisted leaping into speculation, but even cautious researchers admitted the difficulty of fitting 3I Atlas into established categories. The comparisons to Oumuamua, the first interstellar visitor, were inevitable. Both seemed to move in ways that confounded predictions. Both entered and exited with velocities beyond expectation, and both appeared to carry secrets that natural explanations could not fully unlock. Together, they suggested that interstellar wanderers were not simply random debris, but perhaps messengers or even probes, whose journeys we barely understood. The speed itself became symbolic. It was not just a matter of numbers on a graph, but of possibility. Humanity had always looked to the stars and dreamed of traveling among them, but the physics of propulsion had been a barrier. If 3I Atlas had crossed light years to arrive here at such speed, then the universe itself was showing us that faster journeys were possible. The cosmos seemed to whisper that what we thought impossible might already have been achieved elsewhere. Skeptics countered with alternative ideas. Perhaps 3I Atlas was part of a cloud of debris torn from a dying planet, ejected violently enough to cross stellar neighborhoods at alarming velocity. Perhaps gravitational interactions in some distant binary star system had flung it toward us with the same ferocity a slingshot launches a stone. Yet as models were tested, these answers felt incomplete. The energy required remained staggering, the path inexplicable, and the speed unmatched. The human imagination filled the gaps. Stories arose of starfaring civilizations leaving markers in interstellar space, artifacts designed to be noticed. What if 3I Atlas was one such marker, moving too fast for us to capture, but not too fast for us to observe? Its fleeting passage might have been no accident, but a deliberate act of cosmic communication. A reminder that we are not alone, carried across impossible distances at impossible speed. Others saw it as an omen. Ancient cultures often linked comets and wandering stars with signs of change or disaster. The velocity of 3I Atlas might echo those myths, a celestial messenger arriving with the urgency of catastrophe. It crossed the night sky too quickly, too strangely, almost as if hurrying to deliver a message before vanishing into darkness again. As it departed, its speed ensured that we would never see it again. Once gone, it would slip into the abyss, never to return. For all our telescopes and instruments, it offered only a brief glimpse, a fleeting enigma rushing past at a pace beyond our comprehension. Scientists continued to calculate, to model, to rationalize, but the mystery of its impossible speed remained unresolved. It left behind more questions than answers, questions that haunt the silence of the cosmos. In the end, 3I Atlas stands as a defiance of our understanding, a celestial rebel racing through our solar system faster than it should, faster than science could comfortably explain. Its velocity was not just a number, but a challenge, a reminder that the universe still holds secrets far beyond the reach of human certainty. It came and went in a flash, a cosmic whisper carried on the wings of speed, leaving us to wonder if we had just witnessed something greater than we could ever hope to comprehend. The alien-like trajectory. When astronomers plotted the course of 3I Atlas through our solar system, they expected to see a familiar pattern. Comets and asteroids that pass through follow predictable arcs defined by gravity. They are drawn inward by the sun's pull, slingshotted around, and cast back out into space. It's a dance that celestial bodies have performed for billions of years, one that can be described with elegant equations and Newtonian laws. But 3I Atlas seemed to refuse choreography. Its trajectory was alien, strange, almost willfully disobedient to the path science had charted long before. From the beginning, its hyperbolic orbit raised eyebrows. A hyperbolic trajectory is one that doesn't close into an ellipse around the sun. Instead, it cuts through like a visitor with no intention of staying. That alone marked 3I Atlas as interstellar, a traveler from beyond our system. But what shocked astronomers was not simply its hyperbolic path, but the way it deviated from expected models. Each recalculation suggested small but undeniable discrepancies, as though the object was nudging itself, subtly adjusting its course without a visible cause. Normally, comets exhibit such deviations when sublimating, when ices vaporize under solar heat, releasing jets of gas that act like tiny thrusters. This is called outgassing, and it can alter a comet's path slightly. But 3I Atlas did not display the hallmarks of outgassing. There was no visible tail, no coma, no plume of vapor that could account for the changes. Yet still, its trajectory shifted. It was as if the object was steering, correcting, or propelled by something unseen. The alien-like quality of its motion grew harder to ignore. Observatories across the globe compared data, trying to find consistency. Was it our instruments? Human error? Or was the object itself demonstrating a form of motion unseen in natural celestial bodies? Each possibility carried weight, but none dissolved the mystery. If natural forces weren't responsible, then what was? Some scientists whispered theories that bordered on the forbidden. Could 3I Atlas be a probe? The comparison to Oumuamua was inevitable. That first interstellar visitor had sparked debates about whether it might have been artificial, its trajectory likewise mysterious. 3I Atlas appeared to follow in its footsteps, another wanderer whose course could not be explained by gravity alone. The idea gained traction. What if such objects weren't accidents of interstellar drift, but something else entirely? Devices programmed to pass near stars, to gather information, to announce presence. Others sought more terrestrial answers. Perhaps it had encountered a field of interplanetary dust or charged particles that altered its velocity slightly. Perhaps its composition was unusual, made of exotic ices invisible to our instruments, creating faint sublimation effects too subtle to detect. Yet each explanation faltered against the data. No tail, no jets, no clear evidence of external influence. The numbers stood on their own, daring scientists to explain the unexplainable. The trajectory also raised questions about intent. Natural bodies are indifferent. They follow the dictates of physics without preference. But 3I Atlas seemed to behave differently. Its course brought it unusually close to Earth's orbital neighborhood, close enough to ensure human detection. The odds of such precision sparked uncomfortable speculation. Was it coincidence, or was the trajectory chosen? If chosen, by whom or by what? In mythology, wandering stars often carried messages. To the ancient world, their unexpected paths meant signs, omens, warnings. 3I Atlas, with its alien-like trajectory, seemed to echo those ancient fears. It crossed the sky not as a harmless pebble, but as a stranger with purpose. And like the comets feared by medieval chroniclers, it seemed to arrive with an agenda hidden in its erratic motion. The alien trajectory theory found its most provocative support in the idea of solar sailing. Some astronomers proposed that, like a spacecraft equipped with a thin reflective sheet, 3 Atlas might have been propelled by radiation pressure from the sun itself. If it were broad and flat, light could have given it a gentle but persistent push, altering its path in ways we observed. But such a structure, fragile and artificial, would be unlike anything nature produces. Could 3I Atlas have been built? If so, it was not just alien-like in trajectory, but alien in origin. Even if one sets aside speculation about alien probes, the physics remained baffling. To move, as 3I Atlas did, required precision. Its hyperbolic curve bent around the sun with mathematical neatness, but then twisted subtly as it departed. Small deviations accumulated into a clear statement. This was not the orbit of a comet simply obeying gravity. Something else was at work. And the more scientists tried to fit it into models, the more it resisted explanation. For astronomers watching in real time, the experience was surreal. Here was an object behaving in ways that textbooks said it shouldn't. Observations trickled in from Hawaii, Chile, Arizona, Europe, each confirming the strangeness. At conferences, researchers debated heatedly. Was it wrong to invoke the possibility of intelligence? Was it reckless to admit that the trajectory seemed deliberate? To some, entertaining those ideas was dangerous, like a slide into pseudoscience. To others, refusing to ask was arrogance, an unwillingness to face evidence that the universe might be stranger than we wish. The alien-like trajectory also hinted at something larger. If 3I Atlas was not unique, but one of many interstellar travelers with strange paths, then our solar system might not be a quiet corner of the galaxy. It might be a crossroads, visited more often than we know. If its path was chosen, then perhaps it was chosen because Earth was here to notice. The thought lingers like an echo. What if we were meant to see it? As 3I Atlas slipped away into the depths, its course continued to puzzle. It left astronomers with data, but no closure. The strange deflections in its trajectory remain unexplained, filed under anomalies. And anomalies in science are both maddening and inspiring. They point to the gaps in our knowledge, the cracks where new truths may emerge. What, then, was 3I Atlas? A natural body with unknown composition, pushed in ways too subtle to detect? Or something else? A probe, a messenger, a fragment of intelligence cast into the stars? Its alien-like trajectory refuses to give up the secret. All we can do is look back at the path it carved across our system, a path too deliberate, too strange, too alien to dismiss. In the silence of the night sky, the questions linger. An object came from nowhere, crossed our neighborhood on a path that mocked prediction, and vanished again into the void. We call it a comet, a rock, a visitor. But those names are veils. Behind them lies the unsettling truth. Its trajectory was alien, not because it came from another star, but because it behaved like nothing we had ever seen. And in its fading trail, it left us with a single haunting thought. Perhaps we had just been watched. A shape no telescope can agree on. When astronomers first trained their instruments on 3I Atlas, they expected to capture a fairly ordinary silhouette. Interstellar objects like comets or asteroids typically reveal shapes that, while irregular, fall within the range of the familiar. Rocky fragments, icy lumps, elongated shards, or potato-like forms shaped by time and collision. Yet with 3I Atlas, the very question of what it looked like became one of its greatest mysteries. Every observation told a different story. Some saw a thin shard, others a flattened disk, and still others reported an object flickering between states, as if it were more illusion than reality. Its shape, more than anything else, came to symbolize its defiance of science. The earliest telescope images suggested elongation. When its brightness was plotted against time, astronomers noticed variations that implied tumbling. If an object spins, its reflected light rises and falls, creating a pattern. For a familiar asteroid, those patterns are regular and predictable. But with 3I Atlas, the pattern was chaotic, erratic, and unlike anything previously documented. Some models suggested it might be 10 times longer than it was wide, an almost cigar-like shard hurtling through space. Others, however, saw the opposite. A broad, pancake-flat disk flipping through the void like a cosmic coin. Neither interpretation satisfied everyone, and both pushed against the boundaries of what natural celestial bodies were thought to form into. The confusion deepened as different observatories compared notes. One night, it seemed elongated, the next, oddly flattened. Was it tumbling in a complex way? Or was its surface so reflective and uneven that light itself played tricks on our instruments? For some, the possibility arose that the object was not solid at all, but a fragmented cluster loosely bound together, changing its silhouette depending on the angle. But that too would have likely produced debris trails, which were absent. Instead, 3I Atlas glided forward intact, its form elusive. The debate over its shape was not mere academic curiosity. Shape determines origin. An elongated shard suggests violent ejection from a shattered planet or star system, while a flattened disk hints at processes we do not fully understand. perhaps even something constructed. Theories spiraled outward. Could the object be a fragment of a planetary crust ripped away in some interstellar cataclysm? Or could it be, as some dared to whisper, a sail, thin, wide, and designed to catch starlight for propulsion? The lack of consensus on its physical form only fueled these unsettling possibilities. Its brightness further complicated the matter. Observers noted strange fluctuations that did not match typical rotation curves. Instead of a steady rhythm, it flickered erratically, sometimes brightening sharply, then fading as if surfaces of different reflectivity were exposed in sequence. This odd light curve could not be reconciled with simple shapes. Natural objects are messy, yes, but even messiness produces patterns. Here the pattern seemed broken, unnatural, resistant to prediction. Some suggested that this was not rotation at all, but a reflection from structured surfaces, angled panels, or fractured mirrors. If so, what kind of object were we looking at? The unsettling fact was this: our best telescopes, instruments capable of peering across billions of light years, could not agree on the shape of something inside our very own solar system. It passed within observational range, yet its form slipped through our grasp like a ghost. The contradiction between the cigar-shaped shard and the pancake disk became legendary in astronomy circles. Entire conferences were devoted to modeling its light curves, building computer simulations of what might account for the data. Each simulation, however, contradicted another. As quickly as a theory was proposed, it was dismantled. The human imagination, confronted with uncertainty, filled the void. To many, 3i Atlas became a mirror for speculation. If it was elongated, perhaps it was a natural shard, but if it was flat, perhaps it was artificial. If it tumbled, maybe it was derelict debris from an alien civilization drifting through the stars. If it shimmered too brightly, perhaps it was powered, emitting faint energy we could not yet measure. In every possibility, the shape, or the lack of clarity around it, became the heart of the mystery. History offered strange parallels. Oumuamua, the first recorded interstellar visitor, had provoked similar debates about shape. It too flickered, elongated in some models, flattened in others. The comparison was unavoidable. Two interstellar objects, arriving only years apart, both refusing to reveal their forms clearly, both playing tricks with light and defying neat categorization. Were they members of a class of objects we simply did not yet understand? Or was something more deliberate at work? One of the most bizarre hypotheses was that 3i Atlas could be a hybrid, part natural fragment, part engineered structure. Perhaps it was once a comet or asteroid, altered by forces unknown, stripped, melted, or reshaped into its current oddity. Others argued it might not even be a single object, but a shell or hollow structure, tumbling in ways that confused our instruments. Hollow bodies can create deceptive reflections, tricking observers into perceiving multiple shapes at once. If true, this would suggest not just strangeness, but design, for what natural process produces hollow interstellar shells. Theories spilled into science fiction territory. Was it a probe disguised as a rock? Was it an ancient derelict, a piece of alien machinery lost to time, now wandering aimlessly between stars? Could the irregular flickering of its surface have been more than random reflection? Perhaps a message encoded in light, too fleeting for us to decipher? For many scientists, such ideas were too speculative to entertain. But for others, the very failure of conventional explanations left the door open. Even attempts to reconstruct its origins stumbled without clarity of shape. If elongated, it might have been hurled from the violent birth of a star system. If flattened, perhaps it came from processes we cannot yet imagine. Each possibility demanded a different origin story, each one as mysterious as the last, and yet no single answer fit neatly with the data. The strangeness of its shape also reminded us of the limits of human observation. Our telescopes are powerful, but they capture light, not truth. When a fleeting visitor like 3i Atlas races past, we see it only in fragments, in flickers of brightness across nights and weeks. We build models, but the models are guesses, shadows of reality. The real shape of 3i Atlas, if ever knowable, slipped away with it back into interstellar darkness. Its refusal to present a single comprehensible form has left it as an enigma. The very title, A Shape No Telescope Can Agree On, is more than poetic. It is a statement of fact. Science thrives on consensus, on shared data leading to shared conclusions. With 3i Atlas, consensus never arrived. Instead, It fractured into competing visions of a rock that might not be a rock, a disk that might not be a disk, a shard that might be something else entirely. In the end, what was 3I Atlas? We cannot say with certainty. Its shape was a puzzle that bent observation into contradiction, leaving us with shadows, flickers, and speculation. It was as if the cosmos itself presented us with a riddle, an object designed to evade definition, to mock our instruments and our need for order. A mystery shaped not by stone or ice, but by ambiguity. A cosmic visitor that reminded us of how little we truly see, even when something passes right before our eyes. And so 3 Atlas drifts away, its form unresolved. To some, it was a shard. To others, a disk. To a few, it was something far stranger. But in every case, it was alien, not merely because it came from the stars, but because it refused to take a shape our science could claim to know. In that refusal lies its greatest secret. Perhaps it was never meant to be understood at all. The mystery of its shimmering glow. When 3I Atlas passed through our solar system, one of the strangest details noted by astronomers was not only its speed or its trajectory, but the way it shone. Its glow seemed to shimmer, flicker, and shift in ways that defied easy explanation. Most celestial bodies reflect light predictably. A comet brightens as it approaches the sun and outgasses. An asteroid reflects sunlight in proportion to its size, surface, and albedo. Yet 3I Atlas behaved differently. Its glow wasn't steady. It appeared to fluctuate with irregular pulses, as if it were cloaked in shifting light. At first, scientists assumed the brightness variations could be explained by rotation. As an irregular object tumbles, it exposes surfaces of differing reflectivity. This produces a light curve, a predictable wave of bright and dim. But the light curve of 3I Atlas was far from predictable. Instead of smooth cycles, the brightness spiked and dimmed erratically, at times far too rapidly to match simple tumbling. Some observers described it almost like a strobe, a flicker that could not be accounted for by ordinary surface reflections. What caused this shimmering? One theory suggested that 3I Atlas had an unusually reflective surface. Perhaps it was coated in exotic ices or metals that caught sunlight and scattered it unevenly. If the surface was crystalline or fractured, the reflections could have acted like mirrors, dazzling telescopes with shifting flashes. Yet this theory quickly ran into problems. Reflective ices would sublimate under the heat of the sun, producing visible tails or comas. 3I Atlas displayed no such evidence. If it were metallic, then it suggested a composition uncommon in natural interstellar objects. The shimmer persisted, unexplained. Another proposal involved a hollow structure. A shell-like body, tumbling irregularly, could produce unusual light patterns. Light might penetrate openings, reflecting within, before bouncing outward in strange sequences. This could explain the erratic flicker, as if the object's glow came not just from its surface, but from within. But such a structure is unprecedented in natural astronomy. Hollow rocks do not survive interstellar journeys. The suggestion veered into unsettling territory. Could the shimmering be evidence of something engineered? The artificial hypothesis gained momentum when some scientists compared the flickering to the behavior of reflective panels. A solar sail, for instance, would gleam brightly when aligned with sunlight and then fade when tilted. If 3I Atlas were broad and flat, as some shape models suggested, its shimmering could be the result of reflective surfaces catching and losing light. This idea dovetailed with speculation that it might be a probe or a derelict craft drifting through space. The shimmering glow in this light was not a trick of observation, but a potential signature of alien technology. Skeptics countered with natural explanations. Perhaps the surface was patchy, with dark regions of dust interspersed with bright patches of ice. As it tumbled, the alternating regions could create the illusion of flickering. Or perhaps the shimmering was an observational artifact, data noise, atmospheric distortion, or instrument sensitivity. Yet the consistency of reports from multiple observatories made these explanations difficult to sustain. The shimmer was real, not a glitch of human equipment. What made the glow even stranger was its persistence. It didn't fade smoothly as the object receded from the sun. Instead, its brightness continued to fluctuate long after scientists expected it to settle. In some reports, it even appeared to brighten slightly during periods when it should have dimmed. This defiance of expectation added fuel to the mystery. It was not behaving like a rock, not behaving like a comet, and not behaving like anything our models could easily predict. The shimmering also echoed ancient symbolism. Across cultures, luminous wanderers in the sky were feared and revered. A star that shimmered unexpectedly was taken as a sign, a portent. In medieval chronicles, comets were often described as flaming swords or ghostly torches, their unsteady glow linked to war, famine, or plague. Three-Eye Atlas, though viewed through modern telescopes, carried the same eerie aura. Its flickering light seemed almost alive, like a beacon or a warning flaring across the void. Theories grew bolder. Some asked whether the shimmer could have been intentional, an attempt at signaling. If Three-Eye Atlas were a probe, the variation in brightness might not be random, but encoded. Perhaps it was transmitting information not through radio waves, but through light, using solar reflection as a natural beacon. If so, humanity failed to decipher the message. Our instruments captured the flicker, but we dismissed it as noise rather than language. The possibility lingers. Did we overlook an interstellar communication written in the shimmer of Three Atlas? Even more radical speculation suggested that the glow might be self-generated. Could it have been emitting its own faint luminescence? Some exotic minerals can glow when struck by radiation, and interstellar journeys expose objects to constant cosmic bombardment. If Three-Eye Atlas contained such materials, its shimmering might have been the result of energy release. But the pattern of flickering was too structured, too uneven to be explained by simple radiation effects. Again, the data refused neat answers. As its time in our skies drew to a close, the shimmering glow became a subject of debate at conferences and in journals. Papers described its irregularities, attempted to model them, and struggled to reconcile the numbers. But no model satisfied all observations. The glow remained ambiguous, an anomaly tucked into the broader enigma of the object itself. For every natural explanation offered, there was a counterpoint pointing toward the unnatural. Some astronomers quietly admitted that the shimmering glow of Three-Eye Atlas might never be explained. Unlike planets, which can be revisited and studied, interstellar visitors offer only fleeting glimpses. They come once, pass quickly, and are gone forever. By the time instruments are pointed and models are tested, the object is already receding into darkness. The glow of Three-Eye Atlas vanished with it, leaving only scattered data points and haunting speculation. And so the shimmering became its legacy. It was not just a quirk of observation, but a symbol of its defiance. Light is supposed to reveal, to clarify, to expose truth. Yet here, light itself became the mystery. The glow of Three-Eye Atlas did not illuminate what it was, but instead deepened the shadows around it. It flickered like a secret, like a cosmic riddle meant not to be solved, but to be remembered. In the end, the shimmering glow stands as a reminder of how much we do not know. Was it reflective ice, exotic metals, a hollow shell, or the glint of something made, not born? Was it a natural quirk of rotation, or a signal meant for eyes beyond Earth? The truth has drifted with Three-Eye Atlas into interstellar night beyond reach. But its glow lingers in our memory, an alien shimmer against the black, mocking certainty and inviting wonder. Three-Eye Atlas was a traveler, a messenger, a fleeting light. And in its glow, irregular, shimmering, and strange, it left us with the most haunting question of all. What or who was shining back at us? The vanishing comet tale. When Three-Eye Atlas first entered astronomers' view, many expected it to behave like a comet. After all, an interstellar visitor sweeping past the sun should reveal itself in familiar ways, warming under the star's heat, releasing jets of gas and dust, and unfurling a long, radiant tail. Comets are, in essence, frozen time capsules, and when the ice that holds them together vaporizes, it creates the iconic trail of light and dust that stretches across the night sky. It was natural to assume Three-Eye Atlas would do the same, but it didn't. The tail that should have been there never appeared, or rather, it seemed to appear only faintly, then vanish again without explanation. At first, some observers reported that Three-Eye Atlas showed the beginnings of a coma, a hazy halo of gas and dust. There were hints of material trailing behind, as though the sun's heat was awakening a frozen body. But just as quickly as these signs were noted, they disappeared. The expected dramatic plume never materialized. Instead, the object continued on its journey with a puzzling emptiness, carrying itself like a comet that refused to be a comet. This vanishing act became one of the defining puzzles of 3 Atlas. For centuries, comet tails have been one of the most spectacular and predictable sights in the sky. Even small comets, when heated by the sun, display a tail stretching millions of kilometers. Why then did 3I Atlas defy this rule? Was it not made of ice at all? Or was something more unusual taking place on its surface, something we had never seen before? One theory suggested that the object might have been covered in an insulating crust. Over eons of drifting through interstellar space, cosmic radiation could have baked its surface into a hardened shell, sealing away the volatile ices within. If this were true, then sunlight might not have penetrated deep enough to cause outgassing. In that case, 3I Atlas would appear as a comet without a tail, a frozen body that had lost its ability to display one of the most distinctive cometary traits. But this theory clashed with early reports that did detect faint activity, however short-lived. Something had started, then stopped. The question was, why? Another idea was that 3I Atlas was composed of materials we had never encountered before. Perhaps its ices were made of exotic compounds that vaporized too quickly or too faintly to leave a visible trail. Maybe its outgassing occurred in bursts, sudden spurts of vapor that vanished before instruments could capture them clearly. This would explain why some telescopes glimpsed hints of a coma while others saw nothing at all. The tail may not have been absent, but ephemeral, slipping in and out of existence faster than our eyes could track. But the most unsettling possibility was that the vanishing tail was not a natural phenomenon at all. Some astronomers and theorists wondered aloud, what if the absence of a tail was evidence of control? If 3I Atlas were artificial, perhaps a probe, perhaps a craft, then it would not display the messy exhaust of a natural comet. Its lack of a tail could be a clue, a sign that it was not behaving according to natural law but according to design. The flickers of faint activity might not have been sublimation at all, but something else entirely. Interference, emissions, or systems at work that mimicked cometary activity before shutting down. Skeptics argued that the tail's disappearance could be explained by simple observational bias. Perhaps the coma was always there, but too faint for many instruments to detect. From Earth's perspective, the geometry of the object's orbit might have hidden the tail from view, aligning it in ways that made it blend with the background. Yet this explanation failed to account for why some telescopes did see fleeting evidence of activity, only for it to vanish. To add to the confusion, comets often fragment as they approach the sun, breaking apart under thermal stress. In fact, the name 3I Atlas itself originates from its discovery by the Asteroid Terrestrial Impact Last Alert System, which initially cataloged it as a comet. Reports emerged that it showed signs of disintegration, as if it were crumbling. This might have explained why its tail appeared faint. Perhaps the body broke into smaller pieces, dispersing the gases before they could form a prominent trail. But this too raised questions. If it had disintegrated so quickly, why was its motion so stable? Why did it still appear intact enough to reflect light erratically long after the supposed breakup? The vanishing tail gave rise to ancient echoes. For millennia, tails of comets were regarded as omens, their fiery appearance streaking across the heavens as messages of doom or change. In medieval chronicles, a comet's disappearance was often interpreted as divine intervention, as though the heavens themselves had concealed a warning. To modern scientists, 3I Atlas's absent tail carried a different kind of omen, the reminder that the universe could surprise us, even when dealing with phenomena we thought we understood. Some researchers framed the puzzle as part of a larger pattern. Oumuamua, the first known interstellar visitor, had also shown no visible tail, despite behaving in ways consistent with comet-like acceleration. Now, 3 Atlas repeated the riddle, offering faint glimpses of a tail only to take them away. Could it be that interstellar comets do not behave like the comets we know? Could the rules of our solar system not apply to wanderers from beyond? If so, what we call normal may simply be local, a parochial view of cosmic diversity. Yet, the notion that both objects displayed comet-like motion without comet-like tails unsettled more than it reassured. If not natural, what were we seeing? 2 back-to-back visitors, both refusing to grow tails, both moving as if under invisible forces. Was this coincidence or pattern? The vanishing tail of 3I Atlas seemed to whisper that there was more to these visitors than random fragments of ice. Perhaps they were something else entirely. For the astronomers who watched 3I Atlas closely, the frustration was profound. Tails are more than visual spectacles. They are data. By studying cometary tails, scientists learn about composition light, about where an object was born, about the conditions of distant star systems. Without a tail, 3I Atlas denied us these answers. It remained mute, a mystery locked in its silence. The absence of evidence became evidence of absence. But absence of what? Ice? Volatiles? Or the very assumption that this was ever a comet at all? The vanishing tail became a symbol of 3I Atlas's defiance. It reminded us that the cosmos does not always comply with human expectation. It refused to be categorized, refused to play by rules that seemed universal. And in that refusal, it carved out its legacy, not as a comet, not as an asteroid, but as something nameless. In the end, the vanishing comet tail leaves us with a paradox. Perhaps the tail was there, but faint, fleeting, invisible to most eyes. Perhaps the object's structure prevented outgassing, locking away its volatiles forever. Or perhaps the absence was deliberate, the mark of something artificial concealing itself in the guise of nature. Whatever the truth, it has already slipped beyond reach, carried into the void along with the fragments of the object itself. All that remains is the memory of a comet that should have burned brightly but instead withheld its light. A wanderer whose silence was louder than a blaze across the sky. The vanishing tail of 3I Atlas was more than a curiosity. It was a challenge. It asked us to question what we believe we know about the universe, and it left behind the most haunting lesson of all. Sometimes what we expect to see is not what the cosmos chooses to show. The fuel that shouldn't exist. When astronomers calculated the acceleration of 3I Atlas as it swept past the sun, they were startled to find that its motion didn't align with expectations. Gravity alone could not account for its speed. The sun's pull, though powerful, seemed insufficient to explain why the object entered and left the solar system with such velocity. Something was adding extra thrust, and yet there was no visible explanation. Unlike comets, it had no great tail of vaporized ice to serve as a natural engine. No obvious jets of gas were detected. It was as if 3 Atlas was running on some kind of fuel that science could not identify, fuel that shouldn't exist. In astronomy, acceleration without visible exhaust is a red flag. Typically, a comet gains extra momentum as frozen material sublimates, solid ice turning to gas and blasting outward, creating thrust like miniature rockets. These jets are measurable, observable, and leave telltale signs: plumes, tails, halos of gas. But 3 Atlas displayed none of these features, or only the faintest hints that vanished almost as quickly as they appeared. Yet the object still gained speed. This meant either we were missing something in our instruments, or 3I Atlas was propelled by forces or fuels beyond our understanding. Some scientists suggested exotic ices. Hydrogen ice, for example, sublimates invisibly, releasing thrust without producing a visible trail. But hydrogen ice is fragile, unlikely to survive long journeys through interstellar space. Others propose nitrogen ice, which might account for subtle acceleration without much of a visible signature. But again, nitrogen ice is rare, and its survival over millions of years seemed improbable. If 3I Atlas had been traveling between stars for eons, how could such volatile substances still be intact? To work, this theory required that the object was young on a cosmic scale, freshly ejected from some alien system. Another idea ventured further into speculation. Perhaps 3I Atlas was powered by fuels unknown to Earth. If an alien civilization had engineered a probe, it might not rely on sublimating ice, but on something designed to endure. It could use radiation pressure on reflective surfaces, a solar sail gleaming invisibly in the dark. Or it might contain internal propulsion, powered by sources we have not yet discovered, fuels that last for millennia, steady and efficient beyond our comprehension. The idea of artificial fuel was unsettling, but it explained what nature could not. The object moved as if it had intent, its course marked by energy without cause. If it was not outgassing in ways we could detect, then perhaps it was not outgassing at all. Perhaps it was driving itself. The absence of a tail became suspicious, a silence hiding something stranger. Could it be that 3I Atlas carried an engine, invisible to us but undeniable in its effects? Yet there were those who insisted the mystery could be solved within natural boundaries. They pointed to the possibility of fragmenting material, tiny bursts of dust and gas too subtle to observe at great distance. These microjets, though invisible, might have imparted thrust, but calculations suggested otherwise. The level of acceleration observed was too high to be explained by small, hidden outgassing alone. Something more was at play, and the numbers did not lie. This left the haunting possibility that 3I Atlas was fueled by processes not natural to our experience. Some theorists drew parallels to technologies humanity itself dreams of. Could it have used antimatter reactions, tiny amounts of annihilating fuel producing vast amounts of thrust? Could it have harnessed the quantum vacuum, drawing energy from the fabric of space itself? These are ideas that border on science fiction. Yet, in the presence of unexplained acceleration, speculation became inevitable. If it was not fueled by anything we knew, then perhaps it was fueled by something we had not yet imagined. The cultural imagination seized upon the concept of the fuel that shouldn't exist. To some, it sounded like a cosmic battery, evidence that 3I Atlas was not merely a rock, but a relic of advanced engineering. To others, it evoked fear. If such fuels are possible, then the builders are far beyond us, capable of crossing the stars with ease while we struggle to send probes beyond our own planets. The fuel became not just a scientific puzzle, but a symbol of the gap between human understanding and cosmic possibility. There's another layer to this enigma. If 3I Atlas truly had fuel that should not exist, why did it choose to pass through our solar system? Was it a random visitor, or was it traveling along a course deliberately aimed to intersect our neighborhood? Some suggested it might have been drifting for ages, conserving its strange fuel, until chance brought it near us. Others argued it was evidence of intention, an object that burned its fuel to alter its trajectory to ensure it came close enough for us to notice. The shimmering glow and alien trajectory suddenly made sense in this light. Together, they pointed to a craft using propulsion we could not yet explain. For ancient peoples, wandering stars and fiery comets were thought to be vessels of gods or spirits. They streaked across the sky, burning with otherworldly fuel. Modern science has stripped away that mythology, grounding comets in ice and dust. But 3I Atlas revived the old wonder, resurrecting the idea that some travelers across the stars might carry power unknown to us. Its invisible propulsion seemed to hint at a fire we could not see, a fire not of this world. Some astronomers warned against overreaching. It is dangerous, they said, to leap to conclusions when data is sparse. But even the cautious admitted unease. The anomaly could not be brushed aside. Something propelled 3I Atlas, and the absence of clear natural explanations left an open wound in our understanding. The object became a mirror reflecting our ignorance. It moved with power, but power we could not identify. It carried fuel, but fuel we could not name. As it departed the solar system, it left no answers behind. Whatever drove 3I Atlas carried it away into the abyss beyond the reach of human telescopes. Its propulsion remains invisible, its fuel a mystery. Perhaps it will drift for millennia, forever burning what we cannot imagine. Or perhaps it will find another system, passing silently as it did here, leaving other civilizations just as puzzled. The fuel that shouldn't exist is more than an enigma. It is a challenge. If nature can produce such propulsion, then our models are incomplete. If intelligence created it, then we are not alone. In either case, it forces us to confront a humbling truth. The universe holds energies we cannot yet touch, powers that move between the stars while we remain bound to our cradle. In the end, 3I Atlas left us with a haunting absence. No visible tail, no measurable exhaust, no simple answer, just acceleration where none should have been, motion powered by the impossible. It ran on something we cannot name, something that bends the limits of science. And as it vanished into the dark, it carried with it the greatest riddle of all. What fire burns across interstellar space, invisible yet undeniable, propelling a traveler through the stars? Whatever the answer, it is a fuel that shouldn't exist, yet somehow, it does. The solar slingshot that went too far. When an object from interstellar space plunges toward the sun, astronomers know what to expect. Gravity grips it, pulling it into a curve. Like a stone whipped around by a sling, the object accelerates as it nears the sun, then whips outward with added speed, carried back into the dark. This maneuver, The gravitational slingshot is a principle we know well. We've even used it to propel our spacecraft beyond the planets. But with 3I Atlas, something was different. The slingshot worked too well. It left the solar system with more speed than it should have gained, as though the sun had given away energy it could not afford, or as though the object had helped itself to extra momentum. The gravitational assist is a predictable process. For planets, it works by exchanging momentum. A spacecraft steals a tiny fraction of the planet's orbital energy, speeding itself up while the planet slows infinitesimally. With comets and asteroids, the same laws apply. Their speeds after a solar pass are calculable, their escape velocities determined by geometry. But 3I Atlas defied those calculations. Its departure velocity did not match expectations. It seemed to have accelerated beyond the point gravity alone could explain, as if the slingshot had flung it harder than physics allows. At first, researchers considered error. Perhaps the initial measurements of its inbound speed were wrong. If it had entered the system faster than thought, its exit would make sense. Yet, repeated refinements of the data confirmed the anomaly. The numbers were sound. 3I Atlas had indeed picked up an unexplained boost during its solar encounter. That boost, while subtle, was real, and it was enough to separate it from the familiar category of comet or asteroid. This over-slingshot became one of the most debated aspects of its journey. What could provide the additional thrust? Some argued that sublimation of exotic ices near the sun's heat might have acted like hidden engines pushing it along. Others pointed to radiation pressure, the gentle but persistent shove of sunlight on reflective surfaces. If 3I Atlas was flat or shiny enough, solar photons might have acted like wind on a sail, but neither explanation fully satisfied. Outgassing should have left traces, a coma or tail. Radiation pressure could not account for the observed acceleration without requiring improbably thin, broad structures. In both cases, the proposed answers strained credibility. The anomaly reminded many of Oumuamua, the first interstellar object. It too had accelerated after its solar pass, baffling scientists who could not find evidence of a tail. Now, with 3I Atlas repeating the puzzle, coincidence seemed unlikely. Two visitors, two slingshots, both leaving with unexplained speed. Was this the signature of a class of interstellar wanderers unknown to science? Or was it the mark of something more deliberate? Some theorists whispered the unspoken. What if the solar slingshot wasn't entirely natural? Humanity itself uses the sun's gravity for trajectory adjustments. Could a distant civilization have designed objects to do the same, dropping them into star systems to harvest momentum? If so, then 3I Atlas might not have been random debris, but a craft performing an intentional maneuver. Its trajectory, then, would not be accident, but navigation. And its extra boost, the slingshot that went too far, would be evidence of guidance. This line of thought was provocative. It suggested a universe seeded not with inert stones, but with travelers. Artifacts launched on journeys across light years, designed to visit stars, slingshot past them, and continue. If true, then every unexplained acceleration was not an error, but a message. You are being watched. Yet mainstream astronomy resisted. Some clung to naturalistic explanations, even if incomplete. Perhaps 3I Atlas was fragile, and fragments breaking off during its solar pass imparted thrust. But this would require enormous mass loss, inconsistent with observations. Others suggested magnetic interactions, forces invisible to us that nudged its course. But the evidence was lacking. Each theory fell short, leaving the anomaly unresolved. The cultural imagination, meanwhile, surged. The idea of an object gaining more than it should from the sun struck a chord. Ancient myths described wanderers stealing fire from the gods, or mortals borrowing power from the heavens. 3I Atlas seemed to embody that archetype, a thief in the sky robbing energy from the sun. Its motion was uncanny, almost defiant. Instead of obeying the expected laws, it twisted them, as if declaring that our physics was not the whole story. Some compared it to a stone skipping across water. Normally, the slingshot curve flings a body once and releases it. But 3I Atlas seemed to rebound too sharply, like a stone with hidden spin. This image resonated. A cosmic traveler skipping through star systems, taking more energy than expected each time, leaping from one sun to the next in an endless journey. Could this be how probes, or seeds of some kind, spread across the galaxy, hitchhiking on the power of stars? Even skeptics admitted the numbers were haunting. The solar slingshot was too clean, too sharp. It left scientists with uncomfortable gaps in their equations. Gravity had done its work, but something else had whispered alongside it. And that something, whether exotic physics or intelligent design, left no trace except velocity. The implications ripple outward. If interstellar objects like 3 Atlas can accelerate mysteriously during solar encounters, then perhaps our catalog of comets and asteroids is incomplete. How many have we misclassified, their subtle boosts overlooked? How many interstellar visitors have already come and gone, their paths warped by forces unacknowledged? Perhaps 3I Atlas was not the first to take too much from the sun, but simply the first we noticed. For ancient sky watchers, such anomalies would have been omens. A star that moved strangely, a comet that bent against prediction, these were signs of the divine. Today, we seek equations instead of prophecies, yet the feeling is the same: awe, unease, the sense that the heavens are not fully ours to explain. The sun gave up more than it should that day, and in doing so reminded us of the limits of our certainty. As 3I Atlas sped away, it left behind only data points, arguments, and questions. Did the sun truly slingshot it beyond expectation, or did the object itself provide the missing thrust? Was it a natural shard of ice, or a probe with a mission? We may never know. What we do know is that it behaved like a thief, escaping with stolen momentum, its path mocking our models as it vanished into the black. The solar slingshot that went too far is more than a celestial curiosity. It is a challenge written in motion. It dares us to refine our science, to question our assumptions, and to consider possibilities we would rather avoid. In its wake lies only wonder, a reminder that even the sun, the constant anchor of our system, can be part of mysteries that refuse to bow to human certainty. 3I Atlas came, curved, and fled. In its arc was written a riddle, a slingshot that hurled it beyond comprehension. And as it disappears forever, one truth remains: the universe is capable of lending power we cannot yet account for, and some travelers know how to take it. Signals hidden in the noise. When astronomers pointed their instruments at 3I Atlas, they were not just interested in its speed, trajectory, or missing comet tail. They also wanted to know if it carried secrets in the invisible realm of radio waves and electromagnetic emissions. For decades, the scientific community has speculated that if another civilization ever sent probes into interstellar space, they might emit faint signals, deliberate or accidental, that could be detected if we listened closely enough. With 3I Atlas, that speculation turned urgent. What if, buried in the static of our radio telescopes, there were signals hidden in the noise? The search for extraterrestrial intelligence SETI has long monitored the skies, combing through streams of data for unusual transmissions. When 3I Atlas appeared, SETI arrays and radio observatories worldwide quietly joined the watch. The object's proximity and its inexplicable behavior made it a prime candidate for targeted listening. If anything from interstellar space was ever going to whisper, this might be it. Teams tuned their instruments to frequencies across the spectrum, hoping for a ping, a pulse, or a pattern. What they found, however, was maddening. The data contained spikes, flickers, and anomalies, but nothing that could be immediately claimed as alien. Some signals appeared irregularly, short bursts of radio energy that vanished as quickly as they arrived. To cautious scientists, these were background interference, the hum of Earth's technology bleeding into sensitive instruments. To others, though, the anomalies were too tempting to dismiss. Could they be fragments of communication, faint echoes of a message lost in the cosmic static? The problem lay in interpretation. Radio telescopes always pick up noise, cosmic rays, pulsars, the hiss of the galaxy itself. Distinguishing signal from noise is as much art as science. A true message must repeat, must bear patterns that nature cannot easily mimic. But what if an alien transmission was encoded in ways we don't understand? What if the signal of 3I Atlas was so different from human technology that we failed to recognize it? In that case, the data we discarded as interference might have been something extraordinary. Some researchers suggested that the object's shimmering brightness, the flicker of light as it spun, might itself have been a form of signaling. Instead of radio waves, perhaps it reflected sunlight deliberately, producing pulses too irregular for nature alone. If so, then telescopes may have missed the message by focusing on the wrong spectrum. What if 3i Atlas spoke not in radio but in light? The possibility was unsettling. We may have been staring directly at communication, yet failed to decode it. The anomalies in the radio data fueled speculation in the public sphere. Forums buzzed with rumors of suppressed findings, of scientists unwilling to admit what they had seen. After all, the stakes were enormous. To claim that 3i Atlas emitted signals would be to suggest intelligence, an announcement that would shatter our view of the universe. No wonder some argued that institutions would hesitate, choosing silence over chaos. Whether true or not, the idea spread. Somewhere in the noise, a signal waits. For skeptics, the answer was simpler. Earth's skies are filled with interference from satellites, radar, and communication networks. Any strange burst could be traced back to human sources. And indeed, many of the anomalies were eventually identified as terrestrial contamination. But not all. A few remained stubbornly unexplained, slipping through the sieve of rational dismissal. These lingering blips kept the question alive. Had we caught whispers from something passing among the stars? History, too, weighed heavily on the debate. In 1977, the famous "wow" signal had been detected by the Big Ear radio telescope, a 72-second burst from deep space that has never been explained. For decades, it stood as the tantalizing evidence of contact, a hint that the cosmos might be speaking. 3i Atlas revived that memory. Could this object be the source of another wow signal, fleeting and unrepeatable, a single cosmic hello lost in the static? The parallels were hard to ignore. There was also the question of intent. If 3i Atlas carried signals, were they deliberate transmissions or accidental leakage from some unknown machinery? Human spacecraft emit radio chatter as a byproduct of communication and navigation. An alien craft might do the same. In that case, the noise we detected could be their version of static, the background hum of a technology not designed for us. But what if it was intentional? What if the object was broadcasting, hoping someone, somewhere would listen? The thought lingers. Maybe it wasn't just passing by, it wanted to be noticed. The mystery deepened when some astronomers re-examined the object's erratic light curve. What if the irregularities weren't random but encoded? Could the shimmering brightness have been a form of optical Morse code? Pulsars once baffled astronomers with their rhythmic emissions, initially nicknamed LGM, Little Green Men, before natural explanations were found. With 3i Atlas, the irregular flashes carried the same tension. Natural or not, they looked like a language, a sequence waiting to be cracked. The idea of hidden signals also resonated with the oldest human instincts. Since ancient times, comets and strange stars were seen as messages from the gods. Priests and astronomers charted their appearances, seeking omens in their light. Now, in a modern echo of that tradition, we wondered if 3i Atlas carried a message not from gods, but from other beings. The sky, once thought to be silent, seemed once again alive with whispers. But here lies the cruel irony. If there were signals, we may never know. The object passed too quickly, slipping out of range before deeper studies could be made. Unlike planets or moons, it cannot be revisited. Its noise, if signal it was, is gone forever. All that remains are scraps of data, ambiguous spikes and graphs, and the haunting suspicion that something extraordinary slipped through our fingers. Yet perhaps that is the point. Messages hidden in noise may not be meant for immediate understanding. They may be breadcrumbs scattered across the stars, waiting for civilizations to notice, to wonder, and to search. 3i Atlas may have been one breadcrumb among countless others, drifting probes seeded across the galaxy, each carrying whispers encoded in flickers of light or faint bursts of energy. The fact that we even asked the question, were there signals hidden in the noise, is itself a sign that we are listening. The legacy of 3 Atlas, then, is not only its speed, its trajectory, or its lack of a tail. It is the possibility that in the crackle of our instruments, in the interference we so often discard, there may have been a voice, a faint hello lost among the hiss of the universe. A reminder that the cosmos is vast and we are not the only ones who might choose to send something into the dark. As it fades forever into interstellar night, 3i Atlas leaves us with a question that echoes louder than any answer. Did it speak? If so, we were not ready to hear. We are left only with the noise, and with the haunting suspicion that inside that noise, a signal once called out, waiting for someone to recognize it. And perhaps, if we are lucky, one day another visitor will pass, and this time we will know how to listen. The messenger hypothesis. When 3I Atlas streaked into our solar system, its speed, its trajectory, its shimmering glow, and even its vanishing comet tail defied the explanations astronomers reached for. But perhaps the most haunting possibility to emerge from its brief passage was not about what it was, but about why it came. A growing circle of scientists and thinkers began to wonder if 3I Atlas was not a random fragment of rock or ice at all, but a messenger, a deliberate envoy from another star system, perhaps even from another civilization. This speculation, called the messenger hypothesis, transformed the object from a celestial oddity into a potential cosmic communication. The hypothesis begins with a simple question. What if 3I Atlas's anomalies are not flaws in our measurements, but signs of intent? The unusual acceleration, the absence of a tail, the shifting glow. These could all be interpreted not as mysteries of natural physics, but as features of design. Its path through our solar system brought it close enough to be noticed, yet swift enough to remain untouchable. Its very fleetingness became suggestive. Like a courier delivering a message, it appeared, it drew our attention, and then it was gone. For those entertaining the messenger hypothesis, the object's timing raised eyebrows. Oumuamua, the first known interstellar visitor, had passed by only a few years earlier, stirring debates about alien probes and solar sails. The arrival of 3I Atlas seemed almost scripted, as if the universe, or something beyond it, wanted to reinforce the message. Two strange visitors in such short succession defied probability. Could this be coincidence? Or was it sequence? Were these objects part of a chain of messengers, each dispatched across the galaxy to awaken awareness in emerging civilizations like ours? Advocates of the hypothesis pointed to the practical advantages of such messengers. Sending physical probes across light years might be easier than sending signals. Radio transmissions dissipate. Light pulses fade. But a probe, an object that can coast through interstellar space for millions of years, endures. If seeded in large numbers, some would inevitably pass through inhabited systems. They would not need to broadcast loudly. Their mere presence, their anomalous behavior, would be the message. The cosmos itself would become the medium. The act of being noticed was the communication. The messenger need not even carry technology in the traditional sense. Its message might be embedded in its very behavior. An object that accelerates without a tail, that shimmers as if coded, that follows a path too precise to be chance. These are signals of intelligence disguised as anomalies. Instead of words, the message is a question. Are you watching closely? If a civilization notices, it proves its readiness to detect and wonder. If it does not, the messenger simply moves on, leaving the message unreceived. The philosophical weight of this idea is staggering. For millennia, humans have looked to the heavens for signs, from comets viewed as omens of doom to stars charted as divine messengers. In modern times, we have dismissed these as superstition, yet here was an interstellar object whose strangeness resurrected the same questions. Was 3I Atlas, in some unfathomable way, a continuation of that ancient tradition? Not a god's messenger, but a civilization's? If so, then the ancients may not have been entirely wrong to see the skies as communicative. Perhaps they glimpsed other messengers in their times, described in myths because science had not yet been born. Skeptics, of course, push back. They argue that the messenger hypothesis is too extraordinary, that anomalies should not immediately be attributed to intelligence. Natural explanations, even incomplete ones, are more probable than invoking alien intent. They remind us of Occam's razor. The simplest answer is usually best. Yet the messenger hypothesis persists because the simplest answers, outgassing, dust fragments, radiation pressure, did not fully fit. The messenger idea may not be simple, but it feels consistent. It ties together loose threads of data into a coherent narrative, however unsettling. One version of the hypothesis imagines that such messengers are ancient. Perhaps 3I Atlas was launched long before humanity walked the Earth. It could be millions of years old, part of a vast network of probes seeded through the galaxy. If so, then its mission is not to communicate actively but passively, to show up, to be seen, and to provoke thought. Its builders may be gone, its origin system distant, but the message lives on in its presence. We were here, and we knew you would see this. Another version is more immediate. What if 3i Atlas is not ancient but recent? What if its path through our solar system was calculated, its timing chosen to coincide with our technological awakening? In this version, the messenger is not a relic but an active probe, dispatched to test whether Earth has reached the stage of detection. Its anomalies are deliberate nudges, breadcrumbs left for us to follow. And in that sense, the message is both simple and profound. You are not alone, and you are ready to know it. The idea of the messenger also carries warnings. What if the message is not friendly? History teaches us that messengers are not always bearers of good news. In myths and chronicles, messengers bring tidings of war, plague, or divine judgment. If 3i Atlas was designed to be noticed, what if its purpose was to remind us of our vulnerability? To demonstrate that someone, somewhere, can send objects across light years with precision? Perhaps the message is not "Welcome to the galactic community," but "Remember your place." The psychological effect of this possibility cannot be ignored. Humanity has long craved contact with other civilizations, imagining greetings, alliances, or exchanges of knowledge. But the messenger hypothesis forces us to confront a different reality. What if the first communication we receive is wordless, cryptic, and impossible to answer? What if the message is not a dialogue but a monologue, a demonstration of power or presence? What if the cosmos is not offering conversation but delivering reminders that we are small, watched, and not in control? And yet, there is another perspective. The messenger hypothesis need not imply threat. It could be a gesture of patience. Civilizations that survive long enough to travel the stars might choose subtlety over spectacle. Instead of overwhelming us with undeniable evidence, they might leave puzzles, objects that force us to think, to debate, to expand our science. In that sense, 3i Atlas may not have been a messenger in the human sense of delivering information, but a teacher offering mystery as lesson. The message then is not a sentence, but a challenge. Learn, wonder, question. As it vanished into interstellar darkness, 3i Atlas left no inscription, no plaque, no beacon. It left only motion, light, and anomaly. The messenger hypothesis asks us to consider that those anomalies were the inscription. That in its speed, its shimmering, its missing tail, it carried words written not in language, but in physics. To those who choose to see it this way, the message was clear: we are not alone, and the universe speaks through the visitors it sends. But here lies the haunting paradox. If 3i Atlas was a messenger, its message may never be deciphered. It came too briefly, too fast, too far. We saw it, but we could not capture it. Its secrets slipped beyond reach, leaving us with speculation and wonder. Perhaps that was the point. Perhaps the true message is not in the answers, but in the questions it left behind. Questions that force us to expand our science, our imagination, and our humility. In the end, the messenger hypothesis lingers because it captures something deep in the human psyche. We have always looked to the sky for messages. We have always hoped that someone, somewhere, might reach out. And when a strange traveler crosses our path, behaving in ways we cannot explain, we cannot help but wonder, was this the moment? Was this the messenger we have been waiting for? 3i Atlas is gone now, vanishing into the void. But if it was a messenger, then the message has already been delivered. It is not written in a language we can translate. It is written in wonder, in anomaly, in the silence that screams louder than words. And it leaves us with a single haunting possibility, that across the gulf of stars, someone chose to say hello, and we, for a fleeting moment, almost heard it. The ancient prophecies that sound too familiar when astronomers struggle to explain a phenomenon, people often look backward rather than forward. History is filled with stories of strange objects in the sky, fiery comets, wandering stars, and celestial intruders that terrified civilizations and left their mark on prophecy and myth. With 3 Atlas, a visitor that seemed to defy science, many began to wonder, had we been warned before? Could ancient prophecies, written thousands of years ago, have anticipated the arrival of something like this? The parallels are uncanny, the echoes too familiar to dismiss without unease. Across cultures, prophecies linked heavenly wanderers to upheaval. In Mesopotamia, clay tablets record omens associated with stars that do not belong, strangers that cross the skies outside the fixed constellations. To the Babylonians, such appearances were not random. They were signs sent by the gods. A star that arrived from nowhere and departed again was a message of change, often of empire's fall. When 3 Atlas arrived, tumbling silently across the heavens, the ancient words seemed to whisper again. Was this not the very image of a star that did not belong? In the Hebrew Bible, too, prophets wrote of stars that fall from heaven and wanderers set apart from the host. While scholars interpret these as poetic language for meteors or eclipses, some passages read eerily like descriptions of interstellar objects. The book of Revelation speaks of a star named Wormwood falling upon the earth, poisoning waters, bringing fear and uncertainty. While 3 Atlas never collided, its alien-like trajectory through our skies carried the same tone, an omen of strangeness, a cosmic intruder tied to transformation. The Greeks and Romans also feared comets and wandering stars, seeing them as messengers of doom. Pliny the Elder described them as blazing spears and torches sent by fate. When 3 Atlas flashed and shimmered irregularly as though flickering like a flame, some felt the same primal dread. Cicero once argued that comets were portents of the death of great men. In the months of 3I Atlas's discovery, modern observers found themselves asking, though with irony, whose death or downfall it might foreshadow. Yet, it is not only in the West that these echoes appear. In India, Vedic texts describe Dhumaketu, fiery-tailed stars that appear suddenly and vanish. Some are linked to the destruction of kingdoms, others to cycles of cosmic renewal. The word itself means smoke banner, suggesting a comet. But 3 Atlas, with its vanishing tail, felt like a paradoxical fulfillment, the banner that both was and was not. The ancients warned of a sign in the sky that heralded upheaval. Here was one, ambiguous and fleeting, resisting categorization, yet forcing us to look up and wonder. In China, comets and stars outside the zodiac were meticulously recorded in court chronicles. They were called guest stars, and their sudden appearances were linked to the rise and fall of dynasties. The Book of Han describes intruders in the heavens as messengers of heaven's will, whose purpose was to remind rulers of their mortality. 3I Atlas was itself cataloged as a guest star of sorts, an interstellar visitor never bound to our system. The Chinese term feels uncannily accurate, a guest who entered uninvited, stayed briefly, and departed without explanation. The Mayans, too, feared sky wanderers. Glyphs depict blazing visitors interpreted as omens of drought or conquest. The Aztecs recorded the arrival of a smoking star before the fall of their empire, a comet that heralded doom. When 3 Atlas appeared with flickers of brightness but no consistent tail, its very ambiguity seemed to echo these smoking stars, a body that suggested fire but left no plume. The parallels unsettled those who searched ancient texts for meaning, for the stories seemed to align too neatly with the present. Even in Norse sagas, prophecies speak of stars that streak across the heavens before Ragnarok, the world's end. These are not ordinary stars, but ones that wander and burn with unnatural light. 3 Atlas, shimmering strangely as it crossed our skies, seemed almost to wear that costume, a harbinger of endings, or perhaps beginnings, as the myths of Northern Europe foretold. The skeptic will argue that these parallels are coincidence. After all, comets and meteors have always sparked prophecy. Cultures worldwide, lacking scientific explanation, turn to myth. But the messenger hypothesis and the mystery of 3 Atlas breathe new life into these prophecies. If civilizations long ago witnessed objects like it, other interstellar visitors slipping briefly into view, then perhaps their myths were not inventions, but interpretations of real events. If so, ancient texts may not just be poetry, but partial records of encounters with wanderers like 3I Atlas. This possibility is both thrilling and terrifying. Could it be that humanity has seen such messengers before, but lacked the technology to study them? Could the blazing torches and smoking stars of antiquity have been earlier interstellar visitors, misunderstood yet faithfully remembered in prophecy? The recurrence of themes, the wanderer, the omen, the messenger, feels less like coincidence and more like a pattern repeating across ages. The question deepens when we consider timing. Many of these prophecies emphasize not just the strangeness of the star, but its role as a herald of change. What if 3I Atlas's arrival in our own time is symbolic in the same way? Humanity stands at the edge of enormous transformation: climate crisis, technological upheaval, the dawning of space exploration. To see a cosmic visitor now, when we have the tools to notice its anomalies, feels almost scripted. It is as if the prophecies echo, not because the ancients knew the future, but because the universe itself sends reminders at turning points in history. Some theologians and mystics have gone further, suggesting that 3 Atlas fulfills forgotten or suppressed prophecies. The Ethiopian Kebra Nagast speaks of a wanderer from afar that signals shifts in power and divine reckoning. Medieval chronicles in Europe describe sword stars appearing before plagues and wars. Each echo builds a chorus. The universe does not remain silent. It speaks in wanderers, in stars that should not be there. 3i Atlas, then, becomes the most recent verse in an ancient song. The familiar ring of these prophecies raises a chilling thought. Maybe they were never about specific events like kings dying or empires falling. Maybe they were about awareness itself, the recognition that visitors from the stars would come, and that we must pay attention. The ancients wrapped these warnings in myth because myth was their language. We wrap them in science because science is ours. But both languages point to the same truth. We are not insulated from the cosmos. Visitors arrive. They always have, and they always will. The danger lies in dismissal. If we choose to explain away the parallels as coincidence, we lose the chance to see the bigger pattern. If we take them too literally, we risk paranoia. The middle path is humility, acknowledging that ancient prophecies sound familiar not because they predicted 3 Atlas specifically, but because they preserve a memory of how humanity responds to the unknown. They remind us that the strangeness of the skies has always unsettled us, and that perhaps we are meant to be unsettled. As 3i Atlas fades forever into interstellar dark, its story merges with the prophecies of old. The Babylonians' wandering star, the Chinese guest star, the Aztec smoking star, the Norse omen of Ragnarok, they all converge here in this one fleeting visitor. Too familiar, too resonant, too strange. Whether coincidence, archetype, or cosmic design, the echoes remain. And so we are left with a question that bridges past and present. Did the ancients see what we see now? Were their prophecies born from fear or from faint recognition of patterns beyond human scale? Whatever the answer, 3i Atlas has revived their voices. It passed through our skies not just as an interstellar rock, but as a mirror, reflecting the stories humanity has always told about the heavens. And in those stories, we find a chilling familiarity, as though they were waiting for us to remember why it shouldn't have survived. The mere fact that 3i Atlas arrived intact in our solar system is a mystery in itself. By all accounts, an interstellar traveler should not have made it here in one piece. The vast gulfs between stars are hostile beyond imagination. Space is not a silent emptiness, but a minefield. High-energy cosmic rays, colliding dust particles, gravitational tides, and the slow but relentless erosion of radiation. Over millions or billions of years, any object adrift in this void should crumble, fracture, or disintegrate into debris too small to ever be noticed. Yet here was 3i Atlas, whole enough to dazzle telescopes, solid enough to alter our equations, mysterious enough to defy survival itself. The odds were stacked against it from the start. To understand why, consider the environment of interstellar space. Dust grains traveling at tens of kilometers per second strike with the force of bullets. Over 1 million years, countless impacts would erode the surface of any rock or ice into rubble. Radiation from distant stars and the galaxy's background would bake and crack it, stripping volatiles, weakening its bonds. If 3 Atlas had truly wandered for untold millennia, it should have been reduced to fragments invisible to even our most sensitive telescopes. Instead, it appeared as a coherent object, tumbling strangely but undeniably whole. This contradiction was the first clue that something about its survival didn't make sense. Some scientists argued that perhaps it was young. Maybe 3i Atlas had only recently been ejected from its home system, flung into interstellar space by the collapse of a planet or the birth of a new star. If its journey measured in thousands of years rather than millions, then survival seemed plausible. But this explanation quickly faltered. Its velocity was too high, suggesting it had traveled great distances, perhaps across multiple stellar neighborhoods. To be moving so fast, it must have been wandering for ages. Yet if it had, the odds of it arriving intact were infinitesimal. Another problem was its composition. If it were icy like a comet, its surface should have evaporated long ago, stripped bare by cosmic radiation. If it were rocky, repeated collisions with dust should have chipped and fractured it. The fact that 3I Atlas remained reflective, shimmering with inconsistent brightness, implied surfaces neither eroded nor dulled by time. It looked too fresh, too intact for an object that had supposedly voyaged across light years. This paradox birthed more unsettling theories. What if 3I Atlas wasn't entirely natural? What if it had been built to survive the void? An artificial object engineered by intelligence might be designed with resilience in mind. Materials resistant to radiation, structures capable of withstanding impacts, self-repairing surfaces. Such technology would appear miraculous to us, but if it existed, it would explain why 3I Atlas survived when physics says it shouldn't have. Its very intactness could be a clue, a survival too neat to be natural. Even if we set aside artificiality, the problem remains. Some propose that 3I Atlas might be part of a much larger body that shattered recently, leaving fragments still pristine. If so, then we were not witnessing an ancient wanderer, but a fresh piece of cosmic debris. But again, its velocity argued otherwise. For it to move as it did, its ejection must have occurred eons ago. Fresh debris should not be moving so impossibly fast. Each explanation collapsed into contradiction. There is also the matter of thermal stress. When interstellar objects approach a star, the sudden heating is catastrophic. Ice boils, rock cracks, internal pressure builds until fragmentation occurs. Many comets within our own solar system do not survive their perihelion, breaking into clouds of dust. 3I Atlas, however, passed the sun and emerged intact. The vanishing tail suggested activity, but not destruction. Somehow, it withstood conditions that should have torn it apart. To put it plainly, it should not have survived even its brief visit here, much less its long journey before. The survival paradox led some to revisit ancient myths. Cultures across the world described stars that returned across ages, wanderers immune to time. The Babylonians wrote of immortal stars, visitors that came and went yet endured. In Norse myth, signs in the heavens survived until Ragnarok, when the cosmos itself ended. Could 3I Atlas have been one of these? A body that endures where others perish, a messenger not only of strangeness, but of survival itself? The parallels are uncanny, as if ancient peoples glimpsed similar enigmas in their skies and immortalized them in story. For modern astronomers, the survival forced uncomfortable questions about the limits of their models. Perhaps our understanding of interstellar erosion is incomplete. Perhaps there are compositions we do not yet know, substances forged in alien systems that resist cosmic punishment. Exotic ices or minerals unknown to Earth could endure where terrestrial materials would fail. If so, 3I Atlas may be less a messenger and more a sample, evidence of the diversity of matter across the galaxy. But the problem is that such exotic substances are speculative. No known natural material quite fits the data. The haunting possibility lingers. 3I Atlas might be rare because most interstellar travelers do not survive. Perhaps countless objects are shattered and erased by the void, leaving only dust. We saw 3I Atlas not because such wanderers are common, but because it was exceptional, a survivor against impossible odds. Its very presence here is a statistical anomaly, like a single intact artifact washing ashore from a wrecked fleet. If that is the case, then 3I Atlas is a relic of endurance, a needle in the haystack of cosmic destruction. Yet survival brings with it another question. Why arrive now? If it has endured for millions of years, why intersect with our system precisely during the brief era when humans have telescopes to notice? The odds feel uncanny. Some dismiss this as anthropic coincidence. Out of billions of years, it happened to pass during ours because only now do we exist to see it. But others whisper of intention. If survival was engineered, then its arrival was not chance, but choice. It endured because it was meant to endure, and it arrived because we were meant to witness. The implications are unsettling. An indestructible messenger drifting across ages, carrying no words but its own survival. This would be communication of a different kind. It would say, without language, we endure and so can you. Or, more ominously, we endure and we are watching. Either interpretation is chilling, for both imply agency behind the endurance. As 3I Atlas faded into interstellar night, its mystery only grew sharper. Scientists calculated, argued, speculated, but the survival question remained unanswered. It should not have survived its journey. It should not have survived the sun. Yet it did, and in doing so, it defied science as much as it fascinated it. We are left with data points and debates, but no closure. The paradox of its survival may ultimately be its most haunting legacy. A body that should not exist, moving in ways that should not occur, shining with a glow that should not persist, surviving when all logic says it should have died. It was not just a rock passing through the solar system, it was a riddle wrapped in endurance, daring us to explain the inexplicable. In the end, the truth may never be known. Was 3 Atlas a lucky fragment, shielded by chance and composition, slipping through the void intact against all odds? Or was it a messenger deliberately built to endure, a sign sent across ages? Whatever the case, one fact is undeniable. By every law of nature we understand, it should not have survived. And yet, impossibly, it did. That survival, more than anything else, is what makes it unforgettable. The mystery of its surface. When telescopes across the world locked onto 3 Atlas, astronomers expected to learn something about what interstellar objects are made of. The surface of a comet or asteroid tells a story. Ice sublimating into gas, rock scarred by impacts, dust glowing faintly as sunlight reflects off its particles. Yet the closer scientists examined 3I Atlas, the more it resisted explanation. Its surface was unlike anything seen before, sometimes dazzling, sometimes dark, flickering between states that seemed to change from one observation to the next. The mystery of its surface became one of the most unsettling puzzles of its fleeting visit. At first, reports described it as bright, almost mirror-like. Its albedo, the measure of how much light it reflects, seemed unusually high. But then, at other angles, it appeared strangely dim, darker than expected for a comet, absorbing more light than it should. These variations were not smooth or predictable. They shifted erratically, as though the object's surface was patchwork, a chaotic quilt of reflective and absorptive regions. Some even described it as shimmering, as if parts of it glinted like metal while others swallowed light completely. Natural explanations were proposed. Perhaps 3 Atlas had an uneven surface, fractured by collisions and coated in different materials. Shiny patches of ice could reflect brilliantly, while darker regions of dust or rock absorbed sunlight. As the object tumbled, telescopes would catch alternating glimpses of each, producing the odd flicker. Yet this theory fell apart when scientists noticed that the brightness changes did not always match simple rotation models. Sometimes the shifts were too sudden, too sharp, almost like deliberate flashes rather than random reflections. One of the most troubling details was the absence of a visible coma. Comets, when heated by the sun, vent gases that create halos of mist and dust. This process usually coats their surfaces in a layer of material that scatters light evenly. But 3 Atlas showed no such halo, leaving its bare surface exposed. This meant the flickering could not be explained by gaseous activity alone. Instead, the surface itself seemed responsible. Something about its very nature was different. Some speculated that it might be metallic. A metallic surface could explain the mirror-like glints and perhaps even the irregularity of its reflection. But where would such a metallic interstellar object come from? Metals suggest planetary origins, fragments of worlds torn apart by cataclysm. If 3I Atlas were such a shard, then it carried with it the ruins of an alien system. Its surface would be a grave marker of cosmic destruction. Others proposed crystalline structures. Exotic ices, hardened by eons of cosmic radiation, could form surfaces that refract and scatter light in unpredictable ways. These crystalline layers might flash as the object spun, producing the illusion of intentional signaling. But again, if such ices were present, they should have sublimated when it neared the sun. The lack of a tail cast doubt on this theory. It was as if the surface was impervious to heat, resistant to forces that tear ordinary comets apart. The most provocative speculation, of course, was artificiality. If the surface behaved like a reflective panel, perhaps it was designed to. The glints might not be random at all, but engineered, signals disguised as natural flicker. In this view, the mystery of the surface was not a puzzle of geology, but of technology. It could be a sail, a shield, or even a fragment of a long-dead probe, coated in materials meant to survive interstellar travel. The variations in brightness would then be less about chance and more about purpose, as if someone wanted the object to be noticed. Mainstream scientists resisted such conclusions, preferring to search for natural explanations. They suggested that the surface may have been layered, its outer crust weathered differently in different regions. Radiation could have carbonized one area while leaving another relatively intact, creating a stark contrast in reflectivity. As it tumbled, the mix of bright and dark regions would confuse observations, yet even this answer left gaps. The rapidity and irregularity of the flickering seemed to defy the sluggishness of natural rotation. The surface mystery only deepened when compared to Oumuamua, the first interstellar visitor. Oumuamua also displayed odd brightness fluctuations, as though its surface too was irregular in ways that defied easy categorization. Two visitors, both with puzzling surfaces, both reflecting sunlight in anomalous ways. This pattern made coincidence feel less convincing. Was there something about interstellar objects in general that gave them such alien surfaces, or were these two examples part of a stranger class altogether? Adding to the enigma, some observers reported that 3I Atlas seemed to change not just brightness but color. At times it reflected a slightly reddish hue, at others a pale, silvery tone. This might suggest a mix of materials, iron-rich dust producing redness, icy patches reflecting white, but again, without a coma, the evidence was thin. The color shifts could not be pinned down, leaving open the haunting possibility that the surface was more dynamic than static, more active than inert. For ancient peoples, surfaces mattered too. Chroniclers described comets as having faces, sometimes bright and fiery, other times dark and ominous. The shimmering, light, flickering appearance of 3I Atlas would have matched their descriptions of heavenly portents perfectly. In a way, the object fulfilled their prophecies not by its path or speed, but by its visage, its face in the sky, changing and strange, too alive to be dismissed. Scientists debated furiously. Was it rocky, icy, metallic, crystalline, or something else entirely? Each proposal collided with the data, none fitting neatly. The surface seemed to mock our categories, refusing to settle into one. It was neither comet nor asteroid, neither bright nor dark, neither stable nor unstable. It was all of these at once, a paradox of matter that resisted definition. The mystery of the surface also held implications for survival. If it were metallic or crystalline, that might explain why it endured interstellar space when others would have disintegrated. Its skin may have been its shield, preserving it against radiation and collisions. If so, then the secret of its survival lay on its surface, encoded in materials we have not yet encountered. To solve the riddle of 3I Atlas is to solve the riddle of endurance across the stars. As it vanished into the void, telescopes captured their last glimpses of its flickering skin. The data remains, but interpretation drifts like dust. Was the surface natural, exotic, or engineered? Was it shimmering accidental, or was it the echo of design? No one can say with certainty. What is certain is that its surface was as much a message as its path or speed, a visible riddle etched into matter, daring us to solve it. Perhaps the greatest lesson of the mystery is humility. We assume that by pointing instruments at the heavens we can peel back the truth, but sometimes what we see only multiplies the unknown. The surface of 3I Atlas was not a revelation, but a mirror, reflecting not just sunlight but our ignorance. It glimmered strangely, and in that glimmer, it reminded us that the universe is not obliged to make sense. In the end, the mystery of its surface remains unsolved. Was it rock, ice, metal, or something beyond our science? Was the flicker a trick of physics or a whisper of intent? Whatever the truth, it left us with awe. A surface that should have revealed answers instead concealed them, shimmering like a secret on its fleeting passage through our skies. And as it disappears forever, we are left with a haunting thought. Maybe the surface itself was the message, the acceleration that had no cause. When astronomers tracked the path of 3 Atlas through the solar system, they noticed something unnerving. The object wasn't just moving fast, it was accelerating. After rounding the sun, it began to drift off course, picking up a small but measurable increase in velocity that could not be explained by gravity alone. Even more puzzling, the usual culprit for such anomalies, outgassing from sublimating ices, was absent. There was no visible coma, no tail, no jets of vapor to act as thrusters. The acceleration seemed to appear from nowhere, as if the object was pushing itself without a visible engine. It was, in the plainest terms, an acceleration that had no cause. In astronomy, unexplained acceleration is a red flag. Comets do this all the time, but always with visible evidence. When the sun heats a comet, frozen gases vaporize and shoot outward, giving the body a tiny shove in the opposite direction. These microjets are well documented, their effects predictable. But 3I Atlas did not play by those rules. Telescopes searching for activity saw none. Its surface was bare, its path too clean, its absence of a tail undeniable. Yet still, the acceleration persisted. At first, scientists considered error. Perhaps the observations were skewed or the instruments misaligned, but the anomaly remained even after careful recalibration across multiple observatories. Independent teams confirmed the same thing. 3I Atlas was gaining extra velocity as if nudged by an invisible hand. Small though the increase was, it mattered. In the precise language of orbital mechanics, even a slight deviation is profound. It meant something in the cosmos was happening that current physics could not fully explain. The most conservative theory suggested exotic ices, like molecular hydrogen or nitrogen, that vaporized invisibly. These substances could, in theory, produce thrust without leaving a detectable signature. But problems arose immediately. Hydrogen ice is too fragile to survive interstellar journeys. Nitrogen ice would require a scale and purity almost impossible to imagine. Worse, both would have still left subtle traces of gas or dust detectable by sensitive instruments. None were seen. The invisible ice theory, while appealing, seemed forced. This left open a more radical possibility that the acceleration was not natural at all. When Oumuamua, the first interstellar visitor, had shown similar unexplained acceleration, some scientists had already floated the idea of artificial propulsion. Perhaps it was a solar sail, an ultra-thin structure pushed by sunlight. Could 3I Atlas have been the same? If its surface was broad and reflective enough, the steady pressure of photons from the sun might explain its motion. But again, the data resisted simplicity. Its shape remained contested, elongated, disc-like, tumbling unpredictably. Nothing about it matched the neatness of a functioning sail, and yet the acceleration fit no other model. The alien probe hypothesis inevitably gained traction. If 3 Atlas was not a random fragment, but a designed object, its acceleration could be intentional. It might have been powered by technologies invisible to us or structured in ways that mimicked physics we only half understand. Its course could have been adjusted, not by chance, but by choice. A messenger, a scout, or a relic. Whatever the purpose, the unexplained acceleration became its signature, the one fact that refused to be explained away. Skeptics balked. Extraordinary claims require extraordinary evidence, they insisted, and invoking alien technology when natural physics might still suffice was reckless. They pointed to models of uneven surface heating, subtle rotations, or fragmentation, invisible at our distance. Maybe chunks broke away, creating thrust too faint to register as debris. But again, such processes should have produced observable anomalies, dust clouds, flashes of light, irregular brightness. None appeared. What was left was acceleration without visible cause and silence where answers should be. The cultural imagination, meanwhile, seized upon the mystery. To the public, 3I Atlas became the runaway star rock, a cosmic stranger that moved as if alive. Ancient parallels returned. Prophets once spoke of wandering stars that defied the heavens' order, signs of disruption or divine intent. Medieval chronicles described comets that sped as if chasing something, their erratic motion taken as portents of doom. In modern terms, we framed it differently, but the awe was the same. Here was a star wanderer moving in ways it should not, as if carrying a secret we were not meant to know. The haunting part is how deliberate it all felt. Natural objects obey gravity, their orbits predictable to exquisite precision. 3I Atlas broke that pattern. It refused to be bound, as though shrugging off the sun's authority. Its escape was sharper, quicker, more decisive. To watch it was to feel as though it had chosen its path, accelerating like a traveler who, having delivered its presence, now departed with haste. Some scientists have argued that this might be a pattern. Oumuamua accelerated. 3I Atlas accelerated. Two interstellar visitors in quick succession, both breaking rules, both leaving more questions than answers. If this is not coincidence, then it suggests a class of objects, wanderers from other systems that move under forces we do not yet comprehend. Perhaps interstellar space is seeded with them, probes or fragments, each carrying the same signature of unexplained acceleration. If so, then the universe is stranger than we imagined. There are more exotic explanations still. Some theorists wondered if the acceleration could be tied to phenomena we barely understand, interactions with dark matter, quantum effects at cosmic scales, or forces we have yet to discover. These ideas stretch credibility but highlight a truth. Our physics, as vast as it seems, may not be complete. 3I Atlas could be evidence of cracks in our models, a reminder that the universe is not obligated to fit our equations. And yet, there is an even darker interpretation. What if the acceleration was not a side effect, but a message? If the object was a probe, its unexplained push could be intentional, designed not to reach anywhere in particular, but to demonstrate capability. A way of saying, we can move against the current, we can defy gravity itself. To civilizations that noticed, the message would be clear. You are not alone, and you are being shown. The silence of 3I Atlas, then, would not be emptiness, but eloquence, a lesson written in motion, not words. The implications are unsettling. If such objects can accelerate without visible cause, then our assumption that the universe is inert is false. It means that across the stars, either natural processes we do not understand are at work, or that intelligence has left its fingerprints on the void. In either case, we are not as certain, not as secure as we believed. As 3 Atlas vanished into interstellar space, its acceleration became part of its legacy. It was not spectacular like a comet's tail, not obvious like a blazing fireball. It was subtle, precise, and undeniable, a deviation of numbers, a curve bending slightly off script. But in that subtlety lay its power. Science depends on predictability, and when predictions fail, mysteries are born. The acceleration that had no cause may ultimately be the most enduring mystery of 3 Atlas. More than its shape, its glow, or its trajectory, this anomaly touches the heart of our assumptions of the cosmos. Things should move as gravity dictates. They should obey forces we can see. But this visitor refused. It moved with its own will or with forces beyond our reach. It came, it broke our rules, and it left. We are left now with speculation. Was it sublimation too faint to detect? Exotic ice we have never seen? Or was it something more, technosage, mystery incarnate? We may never know. What we do know is that 3I Atlas accelerated when it should not have, and in that act, it whispered a truth humanity has always feared and longed for. The universe still contains secrets, and sometimes those secrets pass briefly through our skies, reminding us how little we truly understand. The alien sail theory. When telescopes tracked the strange flight of 3 Atlas, one explanation began to stand out among the more radical proposals. The possibility that it was not a rock, not a comet, not even a fragment of some distant planet, but a sail. A thin, broad sheet drifting through interstellar space, propelled not by engines or by sublimating gases, but by light itself. This became known as the alien sail theory, and while mainstream astronomers hesitated to embrace it, the idea captured the imagination of scientists and the public alike. If true, 3I Atlas was not just a visitor, it was technology. The roots of this theory lie in the concept of solar sailing. For decades, humanity has toyed with the idea of using sunlight as propulsion. Photons carry momentum, and though the push is faint, over time it can accelerate a broad, lightweight sail to incredible speeds. NASA's Icaros and light sail projects have tested this principle in miniature, proving that sunlight can in fact move spacecraft without fuel. The physics are sound. If humans can conceive of it, why not others? The anomalies of 3I Atlas made the sail hypothesis tantalizing. It accelerated without a visible tail, as though pushed not by sublimating ice but by radiation pressure. Its surface shimmered strangely, flashing irregularly in ways consistent with reflective material. Its trajectory, too, seemed almost calculated, as if guided by an invisible hand. All these clues fit neatly into the sail theory, a thin sheet tumbling through space, catching sunlight and altering its course without a trace of exhaust. But the most provocative detail was its survival. An object crossing interstellar space for millions of years should erode under dust and radiation. Yet 3I Atlas remained intact, reflective enough to confuse our instruments. If it were a sail, it could have been engineered from materials far beyond our comprehension, ultra-thin, ultra-strong, capable of enduring the void. Such technology would allow civilizations to send probes across light years without fuel, relying only on starlight. It would be a form of cosmic economy, a cheap, patient way to explore the galaxy. Mainstream astronomers, however, bristled at the implications. Extraordinary claims demand extraordinary evidence, and calling an interstellar object a piece of alien technology felt like a leap too far. Critics argued that the sail theory was unnecessary, that exotic ices or natural fragmentation could account for the anomalies. But as each natural model failed to satisfy, the sail idea lingered, refusing to be dismissed. A key moment came when some researchers modeled the acceleration. They found that the numbers matched what might be expected if 3I Atlas were only a fraction of a millimeter thick, thin enough to function as a sail. This was eerie because no natural process is known to produce such structures. Comets and asteroids are bulky, irregular, heavy. They are not delicate sheets drifting like kites. A sail, by contrast, would fit perfectly. The object's behavior matched technology, not geology. The implications of this theory are staggering. If 3I Atlas were a sail, then it was built, then it had a builder. And if it had a builder, then somewhere in the galaxy exists, or once existed, a civilization capable of interstellar engineering. That civilization may have seeded countless sails across the stars, letting them drift from system to system, passive scouts carried only by light. Humanity, by noticing one, may have stumbled upon a breadcrumb in a vast galactic trail. But what was the purpose of such a sail? Some suggested reconnaissance. A thin sheet might carry sensors, transmitting faint signals back to its origin. Others imagined it as a derelict, a relic of some long-vanished species wandering endlessly after its mission was complete. More speculative still was the idea of a message. Perhaps the sail itself was the signal, an unmistakable anomaly meant to draw the attention of any civilization advanced enough to notice. Not communication in words, but in presence. Ancient myths resonate with the imagery. Cultures spoke of sky banners, smoke flags, and heavenly sails. The Vedic term Dhumaketu, smoke banner, for comets, or Chinese references to guest stars, evoke the idea of sails across the heavens. To modern eyes, 3 Atlas could well have been such a banner, a sail unfurled in the sky, drifting silently past, carrying with it meaning we cannot yet decode. Skeptics push back hard. Could nature produce thin, flat objects? Some theorized that fragments of planetary crust, shattered and worn by cosmic forces, might resemble sails, but such fragments would crumble under interstellar punishment. The sail hypothesis, though radical, fit the data better than the natural explanations. For many, that was the most unsettling truth. The least impossible answer was still extraordinary. Philosophers and theologians joined the debate. If 3I Atlas was a sail, then we were not alone, and we had proof. Not of communication, but of presence. Yet the silence was deafening. No signal was heard, no message deciphered. The sail passed by without acknowledgement. Was it derelict? Was it dead? Or was it watching in silence, testing whether we were ready to recognize it? The absence of clear communication only deepened the enigma. Some theorists suggested that 3I Atlas may not have been unique. Perhaps the galaxy is filled with sails, and we have simply begun to notice them. Oumuamua 2 displayed unexplained acceleration, and some had already whispered of solar sailing. If 2 objects in quick succession showed the same anomalies, then perhaps this is not coincidence. Perhaps sails drift through the cosmos like spores, seeded across time and space, some alive, some dead, some still carrying missions we cannot guess. The alien sail theory forces us to confront unsettling questions. What if humanity is late to the game, noticing sails long after they were launched? What if civilizations rise and fall, leaving behind only these drifting remnants? Our first contact may not be with living beings, but with their artifacts, ghost ships of the void, silent sails catching light across eternity. Yet there is also hope. If sails can travel between stars, then so can we. 3I Atlas, if indeed a sail, shows that interstellar travel is not impossible. It shows that there are ways to cross the gulfs without impossible fuels, using only patience and the power of light. In that sense, the alien sail is less a threat than an inspiration. It says, this can be done. Others have done it. You can, too. As 3I Atlas faded into the dark, the sail theory remained unproven but haunting. It left us with more questions than answers, but also with wonder. If it was a sail, then for a brief moment we glimpsed technology from another star, drifting silently past our home. If it was not, then we still faced an object that mimicked a sail so well that our best models could not distinguish. Either way, the lesson is profound. The universe contains shapes and motions we are only beginning to understand. The alien sail theory may never be confirmed. The object is gone, its secrets carried beyond reach. But in the memory of its passage, we are left with an image that will not fade. A thin, glimmering sail drifting across the night, pushed not by engines, but by the light of the sun, as if the cosmos itself had unfurled a banner to remind us that we are not alone. Whether relic, messenger, or accident, 3i Atlas became a symbol of possibility, of strangeness, of contact just beyond our grasp. And perhaps that is the true message of the alien sail. It did not need to speak, to signal, to linger. Its very existence was enough. In its silent acceleration, in its shimmering surface, in its defiance of natural law, it whispered across the void, "We were here, and so can you." Why no two models agree when 3i Atlas swept into the solar system, astronomers raced to build models to explain its strange behavior. They modeled its speed, its tumbling light curve, its trajectory, its missing tail, its unexplained acceleration. But every time one model seemed to fit, another piece of data shattered it. The most frustrating truth of all emerged slowly, painfully, and publicly. No two models agreed. The scientific community found itself in an unusual state of disarray, where consensus refused to form. For an object that stayed within our sights only briefly, 3i Atlas left behind not clarity but confusion, a puzzle box of contradictions. The disagreements began with its shape. Early models suggested it was elongated, cigar-like, based on the way its brightness fluctuated as it rotated. But other teams argued it must be pancake flat, more like a disk flipping end over end. Both models could reproduce parts of the light curve, but neither explained all of it. A third camp suggested it wasn't a single solid body at all, but a loose aggregate of fragments held together in a fragile balance. Yet such a cluster should have disintegrated near the sun. Instead of narrowing toward certainty, the shape debate splintered into factions. Each convinced the others had overlooked critical details. The surface models fared no better. Some assumed it was icy, like most comets, its brightness coming from reflective frost. But if it were icy, why no tail? Others argued for a rocky surface, coated in carbonized dust, which could account for its occasional dimness. But if it were rocky, why did it flash like metal at certain angles? Still others invoked exotic compositions. Nitrogen ice, hydrogen ice, even crystalline structures unknown to Earth. Each proposal solved one mystery while creating another. The shimmer, the flicker, the color variations, all of them mocked the models. Trajectory models only deepened the divide. Standard gravitational simulations showed how it should have moved under the sun's influence, but 3i Atlas refused to follow the script. Its slight but undeniable acceleration required modification. Some models invoked outgassing jets invisible to telescopes. Others pointed to solar radiation pressure. A few suggested hidden fragmentation events. None fit perfectly. Every solution explained something while contradicting something else. The disagreement became not just academic, but philosophical. Were astronomers misinterpreting the data, or were their models themselves inadequate for a phenomenon they had never seen before? The failure of models also highlighted the fragility of certainty in science. Normally, when anomalies arise, models converge as data accumulates. But with 3i Atlas, the data was fleeting, fragmentary, incomplete. Observatories caught it at different times, under different conditions, producing light curves that contradicted each other. Some saw evidence of faint outgassing, others saw nothing. Some measured acceleration stronger than expected, others measured weaker. The margins of error widened instead of narrowing. In the end, the models reflected not certainty, but the limits of what could be known. This lack of agreement had profound implications. First, it underscored how unprepared we are for interstellar visitors. Our tools are designed for predictable comets and asteroids, not anomalies screaming past at impossible speeds. We caught 3i Atlas by chance, glimpsed it briefly, and scrambled to explain what we did not fully observe. Our models were built on Earth's solar system, on local bodies we can track for years. But this visitor was different, alien not only in origin, but in behavior. In the clash of models, we confronted our own provincialism. Second, the disagreement fueled speculation. When natural models fail, artificial theories creep in. The alien probe hypothesis gained traction not because it was proven, but because no natural model could command consensus. If one model had explained everything, shape, surface, trajectory, acceleration, the debate would have ended. But instead, the scientific cacophony left a vacuum. And in that vacuum, ideas like solar sails, alien messengers, or artificial relics found fertile ground. The failure of agreement became the breeding soil of the extraordinary. Third, it reminded us of history. When comets were first studied centuries ago, models failed spectacularly. Were they atmospheric phenomena, celestial wanderers, omens of divine wrath? No two models agreed until centuries of data resolved the question. With 3i Atlas, we find ourselves back in that ancient position, grappling with a phenomenon too brief, too strange, too alien for our frameworks. Perhaps in a century, with more visitors cataloged, a consensus will emerge. But for now, we are in the dark age of interstellar modeling. The disagreements were not trivial. Each carried implications about the object's origin. If it were elongated, perhaps it was a shard ejected violently from a planetary collision. If flat, perhaps it was engineered, a sail designed for interstellar drift. If icy, it might hail from the frozen outskirts of a distant system. If rocky, perhaps it was once part of a crust or mantle. Each model told a different story about where it came from and how it survived. Without consensus, we are left with multiple mutually exclusive origin stories. 3i Atlas is simultaneously a comet, an asteroid, a fragment, and a probe, depending on which model you trust. This plurality of interpretations mirrors mythology. Ancient cultures, too, disagreed on the meaning of wandering stars. Some saw them as divine messengers, others as omens of war, others as harbingers of change. No two interpretations agreed, but all acknowledged the same truth. The visitor was uncanny, outside the ordinary order of things. In this sense, modern science finds itself echoing the ancients, not in invoking gods, but in failing to settle on one explanation. The mystery itself becomes the point. Some astronomers have suggested that the disagreement is permanent, that we may never resolve the true nature of 3i Atlas. It is gone now, speeding away into interstellar night. No future telescopes will capture its surface, no probes will intercept it, no radar will bounce back from its form. What we have are fragments of light curves, scattered observations, partial data sets. From these fragments, countless models can be built, but none can be proven. The object will remain a phantom, forever out of reach, forever argued over. And perhaps that is fitting. Perhaps the lesson of 3i Atlas is not clarity, but humility. We wanted models that agreed, equations that matched, certainty that soothed. Instead, we were given contradiction, divergence, confusion. In the failure of consensus lies a message. The universe is stranger than our frameworks, and sometimes it refuses to fit inside them. 3i Atlas may be gone, but the debates it sparked will outlive it, shaping how we think about every interstellar visitor to come. The failure of agreement also forces us to confront a haunting thought. What if the disagreement is itself the message? If 3i Atlas were engineered, perhaps its purpose was not to communicate in radio signals or flashing light, but to defy categorization. To present itself in ways that no model can reconcile, leaving us to puzzle endlessly. If so, the disagreement is intentional. The chaos in our models is the sign that we were meant to notice. Confusion, not clarity, becomes the communication. In the end, the truth of 3 Atlas may remain locked in uncertainty. It was elongated, flat, icy, rocky, metallic, crystalline, depending on who you ask. It accelerated for reasons unknown. It shimmered without explanation. It survived when it should not have. And every attempt to explain it fractured into competing visions. Why no two models agree may not be a flaw in science, but the essence of the mystery. 3 Atlas was and remains the stranger in the sky, not just because it came from another star, but because it defied every effort to understand it. It mocked our models, split our consensus, and vanished before we could catch it. Its greatest gift to us may not be answers, but the reminder that the universe still holds riddles too vast for agreement. And so we are left with competing models, unresolved debates, and a visitor whose legacy is not certainty, but wonder. A wanderer that slipped through our solar system and left us arguing in its wake, as if to say, "You do not yet know enough to explain me." The missing twin. When astronomers discovered 3i Atlas streaking through our solar system, a thought haunted many of them. If interstellar wanderers are born of violent ejections, collisions, or gravitational upheavals in other star systems, then they rarely come alone. Celestial mechanics predicts that when a fragment is hurled into the void, it is usually accompanied by siblings, other shards launched at similar speeds, following similar trajectories. But for 3I Atlas, no such companion was ever found. This absence gave rise to one of the strangest questions surrounding the visitor. Where was its missing twin? The twin hypothesis rests on simple logic. When planets collide or when stars interact gravitationally, debris doesn't emerge as a solitary traveler. Instead, swarms of fragments scatter outward, their paths diverging over time. These pieces may drift apart across light years, but often they remain loosely associated, like tangling, traveling through the galaxy in families. Our own Oort cloud is proof. Billions of icy bodies orbit together on the fringes of the sun's domain, remnants of the same ancient events. For 3I Atlas to arrive completely alone seemed improbable. Somewhere there should have been a companion, visible or invisible, following or preceding it. Yet all searches came up empty. Early after its discovery, telescopes scanned the skies for faint objects on parallel paths. Nothing. Infrared surveys probed for darker companions, bodies too dim to reflect sunlight. Again, nothing. The visitor had no obvious twin. It appeared to have entered the solar system as a singular anomaly, a lone messenger without siblings. To many, this was statistically unlikely. Something was missing. One possibility is that the twin was there, but unseen. Perhaps another fragment entered the solar system but was too small or too faint for our instruments to detect. A shard only a few hundred meters across, dark and inert, could slip past unnoticed in the glare of stars. Our telescopes, while powerful, cannot map every corner of the sky at every moment. If the twin existed, we might simply have missed it. The thought is chilling. Another interstellar visitor could have swept silently through the solar system at the same time, escaping without a trace. Another possibility is that the twin disintegrated long ago. If 3I Atlas was born of a cataclysm, its siblings may have shattered in interstellar space, eroded by radiation and collisions. Perhaps 3I Atlas was the lone survivor, the last intact piece of a family destroyed by the void. This would make it less of a traveler and more of a relic, a fossil from a system we will never know, carrying with it the absence of its lost siblings. In this interpretation, the missing twin is not hidden but gone, erased by time. Yet, a darker possibility lingers. What if the twin was here, but deliberately concealed? If 3 Atlas was engineered, an alien sail, probe, or messenger, then perhaps it was not alone. Its companion might have been designed to avoid detection, a stealth object following a different path. The visible body, shimmering and anomalous, could have been the distraction, while the real payload slipped by unseen. In this light, the missing twin is not a statistical oddity, but a deliberate ghost, hiding in our blind spots. The thought borders on paranoia, but in mysteries like this, paranoia becomes difficult to dismiss. The absence of a twin also raised questions about origin. If it truly had no companion, then perhaps 3 Atlas was not born of natural processes at all. Maybe it was launched deliberately, a solitary craft sent across the stars. Unlike debris clouds, which scatter in multitudes, a designed object would travel alone. Its missing twin would not exist because none was ever meant to. In this sense, the very fact that it had no sibling could itself be evidence of intent. History, too, whispers of twins that vanish. Ancient records describe comets appearing in pairs, only for one to fade inexplicably. Chinese astronomers wrote of dragon stars that divided in the sky, one burning bright while the other dissolved. Medieval chronicles tell of a comet whose shadow twin disappeared into darkness. These stories, though couched in superstition, echo the same puzzle. Wanderers rarely travel alone, and when one does, suspicion arises. 3I Atlas, a visitor with no companion, seems to embody this timeless enigma. Some theorists speculated that the twin might still be out there, trailing behind in interstellar space. If so, it could enter our solar system centuries from now, retracing the pattern. In that case, 3 Atlas is only the first act of a story still unfolding. The missing twin may not be missing at all, but delayed, fated to arrive when we are perhaps more prepared, or less. If this is true, the object we saw is only half of a pair, and the second half still waits in the dark. Others imagine the twin as a guide. Perhaps in its home system, the fragments were launched in pairs, one visible, one hidden. Together they formed a mechanism, a yin and yang of interstellar travel. If so, then we witnessed only one half of a larger pattern. The missing twin becomes a symbol of incompleteness, reminding us that our glimpse was partial, our knowledge fractured. The truth may exist only in the presence of both, and without the twin, the riddle remains unsolvable. Philosophers have taken the metaphor further. The missing twin, they say, represents the incompleteness of all human knowledge. For every anomaly we detect, there is a shadow we fail to see. For every object like Three-Eye Atlas, there may be a hidden counterpart slipping past our awareness. The twin becomes not a body in space, but an idea, that the universe withholds half its truths, offering us only fragments. The missing half is always elsewhere, out of reach, leaving us forever guessing. What makes the absence so compelling is the expectation of symmetry. Our minds crave pairs, balances, binaries. Where there is one, there should be two. Where there is presence, there should be reflection. Three Atlas broke that symmetry, arriving as a lone visitor where there should have been a family. Its solitude was unsettling, a reminder that not all cosmic stories follow our sense of order. Its missing twin is a void we cannot fill, an unanswered question that deepens the mystery. As it slipped away into interstellar space, the search for its companion faded. No second object was found. No parallel visitor revealed. The sky held its silence. Perhaps the twin was never there. Perhaps it still waits, centuries away. Perhaps it passed unseen, its presence hidden in noise. Or perhaps it was erased before we could know it. Whatever the truth, the missing twin became part of the legend, an absence as meaningful as any presence. The missing twin also invites speculation about intent. If Three Atlas was a messenger, perhaps its very loneliness was the message. To arrive without a sibling is to declare uniqueness, to demand attention. A single traveler draws the eye more than a swarm. Its twin, then, may not be missing at all. It may have been left behind, deliberately absent, so that we would focus on the one before us. In this way, absence becomes design, silence becomes speech. In the end, the mystery of the missing twin remains unsolved. We do not know if Three-Eye Atlas had a sibling, if it was truly alone, or if it was part of a larger unseen pattern. But the absence is itself a clue, one more piece of the puzzle that refuses to fit. The visitor's solitude is as strange as its acceleration, as haunting as its shimmer, as inexplicable as its survival. Perhaps one day we will find the twin, dim, fragmented, or centuries behind. Perhaps we never will. Until then, the missing twin is less an answer than a reminder. The universe does not give us wholeness, it gives us fragments, leaving us to imagine the missing half. And in the silence left behind by Three Atlas, we hear not just what it was, but what it wasn't. A traveler with no companion, a messenger with no partner, a mystery whose twin we may never see. The outsider problem. When Three-Eye Atlas was first identified, astronomers quickly realized it was not a typical member of our cosmic neighborhood. Every comet and asteroid in our solar system belongs to a family. Their orbits can be traced back to the Kuiper Belt, the Oort cloud, or the asteroid belts between planets. Their chemistry makes sense in the context of our sun's formation. Even when they behave strangely, they are still children of our system, bound by its history. But Three-Eye Atlas was different. Its trajectory told the story of an interstellar origin, cutting through the solar system on a hyperbolic path that proved it was a visitor from elsewhere. It did not belong here. This was the essence of what scientists began calling the outsider problem, the struggle to explain an object that matched no known category, no familiar family, no local context. The outsider status was obvious from the start. Its velocity exceeded the escape speed of the solar system, meaning it had not been captured and would not return. Its orbit was hyperbolic, not elliptical, confirming it was merely passing through. But outsider status goes beyond numbers. It also describes the way the object defied classification. Astronomers have labels: asteroid, comet, centaur, dwarf planet. Each comes with a checklist: tails, orbits, surfaces, and behaviors that make sense in solar system terms. Yet Three-Eye Atlas refused to check the boxes. It had no consistent tail, yet accelerated like a comet. It glowed strangely, yet lacked the coma of sublimating ice. It shimmered irregularly, yet left no debris. Every attempt to fit it into a category collapsed. This failure of classification unsettled scientists because classification is how science makes sense of the unknown. To call something an asteroid or a comet is to tame it, to fold it into the patterns we already understand. But an outsider resists taming. It demands new categories, new language, even new physics. 3i Atlas reminded us that our taxonomy of space rocks is parochial, built for one solar system, not the galaxy at large. The outsider problem is therefore also a problem of perspective. We thought our categories were universal, but they may only describe a tiny corner of possibility. Consider its surface. Models suggested reflective patches alternating with dark regions, but none fit neatly. Some scientists suggested metallic content, others exotic ices, others crystalline structures formed in environments alien to our sun. If it were born in another system, its chemistry could be unlike anything we know, molecules rare or unstable here, but common elsewhere. As an outsider, it carried the fingerprint of a foreign origin. But this fingerprint was blurred, unrecognizable in our instruments. We could tell it was different, but not how or why. Its outsider nature also showed in its behavior. Gravity is universal, yet 3i Atlas bent the rules. Its acceleration without a tail echoed Oumuamua, the first interstellar visitor, which had provoked similar debates. Two outsiders in quick succession, both accelerating mysteriously, suggested a pattern, but the pattern was not one we could explain. Were outsiders governed by rules we don't yet understand? Did they carry physics from their home systems that behave differently under our star's influence? Or were they deliberately engineered to act in ways we find inexplicable? The outsider problem even carried cultural weight. Since antiquity, comets and wanderers outside the ordinary order of the heavens were feared as intruders. Babylonian astrologers called them strangers that brought upheaval. Chinese astronomers described them as guest stars, temporary visitors from beyond. The outsider was always a harbinger, a disruption of the cosmic order. In modern terms, 3i Atlas was no different. It arrived unannounced, refused to follow our rules, and left before we could understand it. Its outsider status was not just scientific, but symbolic, a reminder that we are not the center, and that the universe sends strangers into our neighborhood. For scientists, the outsider problem raised practical issues. How do you study a body that comes once and never returns? Our methods rely on repetition, repeated orbits, predictable passes, long-term observation. Outsiders deny us this. They give us a fleeting window, a few months at most, then vanish forever. This makes them both precious and frustrating. We cannot send probes to intercept them in time. We cannot schedule follow-ups decades later. We get one chance, and if our instruments are not ready, the outsider leaves us with unanswered questions. 3 Atlas was a case study in this frustration. By the time telescopes were coordinated, it was already fading, its details slipping into noise. The outsider problem also reshaped how we think about the galaxy. If 3 Atlas was one outsider, how many more are there? Was its arrival a fluke, or do outsiders pass through regularly, unnoticed in the vastness of the sky? Some estimates suggest billions of interstellar objects may drift between stars, relics of planetary formation scattered across the Milky Way. If so, then outsiders are not rare. They are the silent majority, drifting invisibly until one strays into our narrow field of vision. The outsider problem, then, is not one object but a population we are only beginning to glimpse. Speculation took stranger turns. What if outsiders are not accidents at all? What if they are probes, sails, or messengers seeded deliberately? The outsider status would then be not a puzzle of classification, but a statement. They are meant to be alien, meant to defy our categories, meant to remind us that we are not alone. In this reading, the outsider problem is not a failure of science, but a test. The objects confuse us because confusion is the point. Their very strangeness is the message. Even skeptics admitted the outsider problem unsettled them. If 3i Atlas was natural, then our ignorance of its composition and behavior shows how little we understand interstellar material. If it was artificial, then we have already been visited and barely recognized it. In both cases, the outsider is a challenge to our arrogance. It tells us that our solar system is not the template of the universe, but merely one corner of a vast diversity. Outsiders will keep arriving, and we must learn to see them for what they are, not what our categories demand. Philosophically, the outsider problem is a mirror. Humans fear the outsider in every sense, the stranger, the foreigner, the unknown. Three-Eye Atlas embodied that fear in cosmic form. It came from outside, refused to conform, and departed without explanation. It is the perfect metaphor for all that unsettles us, the alien, the inexplicable, the other. To confront it is to confront our own discomfort with not belonging, with being small in a universe where strangers pass through and pay us no mind. As Three-Eye Atlas vanished into the darkness, the outsider problem remained unsolved. It had no family here, no twin, no place in our categories. It was, and remains, the cosmic stranger. A reminder that not everything in the universe fits our boxes, and not every visitor explains itself before it leaves. Perhaps that is the lesson of the outsider problem. Not all mysteries exist to be solved. Some exist to remind us of our limitations. Three-Eye Atlas came, shone, confused, and departed. It left behind only questions, arguments, and awe. And in doing so, it forced us to recognize that the universe is filled with outsiders, and that we ourselves may be outsiders too, wanderers in a cosmos whose true order we have only just begun to glimpse. The outsider problem is not just about Three-Eye Atlas. It is about us. It is about the limits of our knowledge, the fragility of our categories, and the vastness of what lies beyond. It asks us to accept that strangers will come, that they will not explain themselves, and that sometimes the only answer is to watch, to wonder, and to remember that we live in a universe where outsiders pass silently through our sky, defying us simply by existing. A stranger from another galaxy? When Three-Eye Atlas was first identified as an interstellar object, astronomers naturally assumed it had been ejected from another star system within our own Milky Way. After all, most theories of interstellar wanderers involve fragments cast off by young planetary systems, flung into the void by gravitational chaos. But as more data accumulated, an even stranger possibility was whispered among some scientists. What if Three-Eye Atlas did not come from our galaxy at all? What if this visitor was not just interstellar, but intergalactic, a stranger from another galaxy? The suggestion sounds improbable at first. Distances between galaxies are almost incomprehensible. The nearest large galaxy, Andromeda, lies over 2 million light-years away. For an object to travel from there to here would mean surviving journeys across cosmic timescales, enduring environments harsher than interstellar space. Yet the very anomalies of Three-Eye Atlas, the unexplained acceleration, the shimmer of its surface, its refusal to match natural categories, gave life to this speculation. Its strangeness, some argued, might not be because it came from another star. It might be because it came from somewhere far beyond. The velocity of Three-Eye Atlas was one clue. While its speed was consistent with an interstellar trajectory, some calculations suggested it was higher than expected for an object drifting within the Milky Way's gravitational field. Could it have been moving so fast because it originated outside the galaxy entirely, a fragment cast across intergalactic space? If so, then Three-Eye Atlas was more than an outsider to the solar system. It was an outsider to the Milky Way itself. Intergalactic space is not empty. It is filled with faint plasma, scattered radiation, and drifting matter. Objects do cross it, stripped from galaxies during collisions, expelled by supernova, or ejected during the violent births of black holes. Over billions of years, fragments can wander between galaxies like cosmic castaways. If Three-Eye Atlas was such a castaway, it carried with it the history of an entirely different galactic environment. Its composition might have been alien not just to Earth, not just to the Sun, but to everything in our galaxy. That could explain why its surface, trajectory, and behavior were so baffling. It was literally forged under different cosmic rules. The idea of an intergalactic traveler also raises questions about time. For such an object to reach us, it may have been drifting for eons, perhaps since before humanity existed, perhaps even before Earth itself had formed. Imagine a shard launched from a distant galaxy 1 billion years ago, crossing voids so vast that entire civilizations could rise and fall in the time it took to reach us. When we looked at Three-Eye Atlas, we might have been gazing at a fossil older than the Milky Way's spiral arms, a relic of an epoch beyond imagination. But there's a more unsettling angle. If Three-Eye Atlas came from another galaxy, how did it survive the journey? Cosmic radiation, collisions with dust, and the endless battering of intergalactic space should have eroded it to nothing. Yet here it was, intact enough to shine, whole enough to accelerate mysteriously. The survival itself would suggest resilience far beyond what we expect from natural debris. Was it possible, then, that it was not debris at all, but something designed to endure? An intergalactic probe, a messenger meant to travel forever, drifting between galaxies like a seed carried on a cosmic wind? The alien sail theory gains new weight under this interpretation. A thin, reflective craft, engineered to harness starlight, could drift across interstellar distances with ease. But could it drift across intergalactic ones? If so, then 3I Atlas might not be the first intergalactic probe to pass us by. It may only be the first we noticed. And if civilizations exist beyond our galaxy, why would they not send emissaries across the void? Radio signals cannot cross such distances meaningfully, but physical messengers can. A sail, a shard, a durable artifact, these could survive where signals fail. Skeptics argue that such speculation is unnecessary. The galaxy itself provides ample explanations. The Milky Way contains billions of stars, each capable of ejecting debris. Why leap to another galaxy? But the counterpoint is haunting. Why assume every visitor must be local? The cosmos is vast, and just as ships sometimes drift into foreign harbors by accident, so too might fragments from distant galaxies wander into ours. Rare, yes. Impossible, no. Ancient myths resonate strangely with this idea. Many cultures spoke of stars or gods arriving not just from the heavens, but from beyond the sky, a realm outside creation itself. In Polynesian traditions, navigators spoke of lights that came from the Sea of Darkness, beyond the familiar constellations. In Norse myth, Ragnarok is preceded by stars falling from outside the world's circle. To modern ears, these are poetic images. Yet to imagine 3I Atlas as an intergalactic visitor is to give those myths new weight. Perhaps our ancestors intuited that not all wanderers are local. Some may come from beyond even the home of our stars. The intergalactic theory also raises the question of pattern. Oumuamua, too, was baffling. Its acceleration, its lack of tail, its odd shape, all mirrored by 3I Atlas. Could both have shared the same origin? Could they have been fragments, sails, or messengers, seeded not by a nearby star system, but by some distant galaxy? If so, then the Milky Way is not just part of an interstellar network, but part of an intergalactic one, a web of messengers drifting between galaxies like pollen between flowers. If true, then 3I Atlas was a participant in a conversation so vast we cannot yet grasp it. And what if its arrival was intentional? If civilizations exist beyond the Milky Way, sending a probe here would be no accident. It would be deliberate, an act of curiosity, contact, or even surveillance. The message would not be in signals or language, but in the very fact of its presence. We can reach you, even across galaxies. That is both awe-inspiring and chilling. To think that we, a young species barely learning to step beyond our home planet, were brushed by an artifact that had crossed the gulf between galaxies, it's almost too much to comprehend. Yet, even if 3I Atlas was natural, its intergalactic origin would still be extraordinary. It would mean that our skies are not just visited by local strangers, but by true exiles, travelers that have crossed the ultimate frontier. To see such a body is to be reminded that the universe is not compartmentalized. Galaxies may appear separate, but the void between them is not empty. Objects wander, cross boundaries, blur the edges. The Milky Way is not isolated. It is porous, connected, vulnerable to visitors from unimaginable distances. As 3I Atlas vanished back into interstellar night, the question lingered. Was it ours, or was it utterly foreign? Was it a shard from a nearby star, or a relic from another galaxy altogether? We cannot know. Its secrets have slipped beyond reach, leaves only speculation. But in that speculation lies a profound shift. We no longer ask merely where in the Milky Way it came from. We ask whether our galaxy itself is just one port in a larger, endless traffic of cosmic wanderers. The stranger from another galaxy theory may never be proven. It may remain in the realm of speculation, whispered in conference halls and late-night discussions. But the idea has already done its work. It has expanded our horizon, forcing us to imagine visitors not just from other stars, but from other galaxies. It has reminded us that the cosmos is not local, not limited, not small. It is vast beyond comprehension, and in that vastness, strangers can appear at any time, carrying with them mysteries we may never solve. 3I Atlas was one such stranger. Perhaps it was local, perhaps interstellar, perhaps intergalactic. But in its passing, it carried with it a haunting possibility that we are part of a universe in motion, where even galaxies do not hold their secrets tightly, where visitors can cross unimaginable gulfs to brush past our tiny world. A stranger from another galaxy slipping silently through our skies, reminding us that the cosmos is larger, stranger, and more connected than we ever dared to dream. The vanishing point. Every object in the night sky has a story, a place it belongs. Planets circle the sun, comets loop in long, icy arcs, and even distant stars remain fixed in the grand rotation of the Milky Way. They are bound, if not to us, then at least to the vast structures that define the cosmos. But 3I Atlas was different. From the moment astronomers calculated its orbit, they knew it was a visitor, not a resident. Its path was hyperbolic, open-ended, forever unbound. Unlike comets that eventually return, unlike asteroids that circle endlessly, this object had no home in our system. Its destiny was not to come back, but to vanish. And vanish it did, slipping away into the abyss at what scientists call the vanishing point. The vanishing point is not just a coordinate on a map, it is a symbol. For astronomers, it marked the moment when 3 Atlas became too faint to track, its light lost against the background of stars. For humanity, it was the point where knowledge ended, where speculation began. Beyond that point, the object carried its secrets with it, its strange acceleration, its shimmering glow, its absent tail, its outsider nature, all gone into the dark. It was a vanishing not just of light, but of certainty, leaving us only with questions. The vanishing point has always haunted human imagination. Ancient observers wrote of comets that appeared suddenly, burned brightly, and then disappeared as if swallowed by the void. To them, the vanishing was a sign of divine will, a celestial message withdrawn once its purpose was complete. Today we see it through telescopes and equations, but the symbolism remains. The disappearance of 3I Atlas felt less like a rock leaving our skies and more like a story unfinished, a book closed mid-sentence. The strange thing about 3I Atlas is how sudden its vanishing felt. Astronomers had only a brief window to study it. Even the most powerful instruments could not hold it long. It grew fainter, slipped beyond detection, and left no trail behind. Unlike comets that scatter dust, leaving debris fields we can later encounter, 3I Atlas left nothing. It came clean, it departed clean, and it erased itself as thoroughly as if it had never been here at all. This unnerving absence made some wonder if the vanishing was more than natural. Could it have been deliberate? Could the object have cloaked itself, altered its reflectivity, or even activated some form of propulsion to escape observation? Theories like these, though speculative, reflect the deep unease left by its disappearance. The vanishing point also exposes the fragility of human observation. For all our instruments, our arrays of satellites and telescopes, we still lose things. The sky is vast, and visitors like 3I Atlas are fleeting. We caught it only because chance aligned our gaze at the right moment. Had it arrived decades earlier, before wide-sky surveys, it might have passed unnoticed. Its vanishing reminds us that countless other outsiders may have come and gone, unrecorded, leaving no trace but in the myths of ancient peoples who saw lights and strangers in the sky. In a way, the vanishing point is what gives 3I Atlas its mythic weight. If it had stayed orbiting like a captured comet, it would have become ordinary. We would have mapped it, measured it, cataloged it, but its departure, its refusal to linger, elevated it from curiosity to enigma. The fleeting nature of its presence makes it feel like a message. Messengers do not stay, they deliver, then vanish. 3 Atlas followed that script perfectly, leaving us to wonder whether its vanishing was the final act of its message. Some astronomers frame the vanishing point as tragedy. Here was a once-in-a-lifetime visitor, and we were unprepared. By the time we understood its significance, it was already gone. We had no probes to intercept it, no missions ready to chase it. It slipped through our fingers like sand carried off by the tide. The tragedy is compounded by its uniqueness. Objects like it are rare, and though more may come, no two are the same. What we lost in its vanishing was not just one data set, but a singular opportunity, never to return. Others see the vanishing point differently, not as tragedy, but as challenge. It reminds us of the urgency of preparation. If we can build faster probes, better telescopes, more agile missions, perhaps we will not lose the next one. The vanishing becomes a call to action, urging us to be ready for the next visitor, whether natural or artificial. It asks us to see the cosmos not as a static dome, but as a crossroads, where travelers pass briefly and where vigilance is the price of discovery. Philosophically, the vanishing point resonates with something older. It is the same pattern found in myths of gods who appear in disguise, test mortals, and then disappear. It is the pattern of prophets who speak once, then fall silent. It is the archetype of the teacher who leaves before the lesson is complete, forcing the student to wrestle with the unanswered. Three-Eye Atlas vanished not just physically but narratively, leaving us suspended in mystery. Perhaps that is why it lingers in our imagination. Its story is incomplete, and so we keep telling it. There is also the unsettling possibility that the vanishing point is not the end but the beginning. Where did Three-Eye Atlas go? Into the void, yes, but toward what? Its path carried it out of the solar system, back into interstellar space, and perhaps onward to another star. If it was natural, it will wander aimlessly until destroyed or captured. But if it was artificial, perhaps it had a destination. Perhaps it was programmed to pass through star systems, to linger briefly, to be noticed, and then to move on. In that case, its vanishing from our skies might coincide with its appearing in another's. Even now, on some distant world, another civilization might be watching it shimmer, puzzling over its anomalies, asking the same questions we are. This idea transforms the vanishing point from a loss into a connection. Instead of imagining Three-Eye Atlas as gone, we imagine it as continuing, carrying the mystery to others. In that sense, we are part of a chain, one link in a long journey across civilizations. The vanishing is not disappearance, but transition, from our watch to someone else's, from our questions to theirs. The thought is humbling and strange. The object that vanished from us may already be someone else's visitor. Yet for us, the vanishing point is final. We cannot follow it. Our telescopes lose it, our models fail, our instruments fall silent. All we have left are fragments of data, irregular light curves, numbers that refuse to agree. Beyond that, only imagination remains. And imagination is what keeps the mystery alive. We picture it drifting into the black, tumbling, shimmering, carrying secrets in its silence. We imagine it surviving for millions more years, wandering through the dark like a ghost. The vanishing point becomes not an end, but an endlessness, a door that opens not to answers, but to infinite speculation. In the end, the vanishing point is what defines Three-Eye Atlas. More than its acceleration, more than its missing tail, more than its outsider status, it is the fact that it is gone that makes it unforgettable. It passed through, refused to linger, and slipped away. It left us empty-handed, but not empty-minded. Its absence is louder than its presence ever was, echoing in every unanswered question. Three-Eye Atlas is gone now, beyond sight, beyond reach. But in its vanishing, it left behind a paradox. The less we see of it, the more it haunts us. The vanishing point is not just where the object disappeared. It is where certainty ended and mystery began. And perhaps that was its purpose all along, not to stay, not to explain, but to vanish, and in vanishing, to remind us how vast and strange the universe truly is. The final mystery. When Three-Eye Atlas slipped away into the abyss of interstellar night, it left behind no tail of debris, no fragments we could capture, no lingering trace to study. It left only data points, models that refused to agree, and the haunting sense that something extraordinary had passed us by. Its trajectory, its acceleration without cause, its shimmering surface, its outsider nature, all became questions we could not answer. And so, in the silence after its vanishing, astronomers and dreamers alike found themselves grappling with what has come to be called the final mystery. What was Three-Eye Atlas truly, and what did its fleeting presence mean? The final mystery is not simply about classification. Was it a comet, an asteroid, a fragment of ice or rock from another star system? These questions, though unresolved, are almost too small for what Three-Eye Atlas represented. The real mystery is deeper. Why did it come when it did? Why did it behave in ways that seemed to defy natural law? Why did it arrive at a moment in history when humanity had only just begun to search the skies seriously for visitors from beyond? Was it chance, or was it something more? For many scientists, the final mystery is a matter of physics. They focus on the unexplained acceleration, the absence of a tail, the shimmering surface that flashed like metal. These, they argue, are the clues. Solve them, and the object becomes knowable. Perhaps it was composed of exotic ices that sublimated invisibly, producing thrust without a visible trail. Perhaps its surface was crystalline, reflecting sunlight in ways we had never seen. Perhaps it was fragmented, its pieces too faint to detect. Each of these explanations remains possible, yet none can be proven, for the object is gone. The dataset is closed, and in that closure lies the permanence of the mystery. But beyond the physics, others see something larger. The timing of its arrival so soon after Oumuamua, the first known interstellar object, feels uncanny. For billions of years, humanity may never have noticed such wanderers. Then, within a few short years, we witnessed two, both strange, both anomalous, both refusing to fit our categories. Was this coincidence? Or was it a pattern? If a pattern, then what does it mean? Are we living in an era when interstellar wanderers are destined to appear more often, reminders of a cosmic traffic we are only now able to detect? Or are we being shown something, taught, perhaps, that the universe is not as empty as it seems? This possibility leads to the most unsettling interpretation, that 3 Atlas was not random at all, that it was sent, or at least directed. The messenger hypothesis, the alien sail theory, the stranger from another galaxy speculation, all orbit this same gravitational pull of thought. If it was not simply a rock, then it was something more. A probe, a relic, a messenger, perhaps even a warning. The final mystery is therefore not what it was made of, but what it was meant to mean. Did it come to say, "You are not alone"? Did it come to test whether we were watching? Did it come as a scout, a harbinger of others to follow? The final mystery also resonates with humanity's deepest myths. Since the dawn of history, comets and wanderers in the sky have been seen as omens. The Babylonians read them as messages of empire's fall. The Romans feared them as signs of death for great leaders. The Chinese called them guest stars, emissaries of heaven. The Mayans saw them as smoking stars, heralds of change. Each culture sensed something uncanny in visitors that appeared suddenly and vanished without explanation. 3 Atlas is the modern incarnation of that archetype. To us, it is not an omen of kings or plagues, but of something more profound, the reminder that the universe is alive with strangers and that we are not the measure of all things. The final mystery lies also in the silence. If 3 Atlas was artificial, it did not speak. It broadcast no signal, sent no message in radio or light. Its silence was total, save for the enigmas of its behavior. Yet silence itself can be a form of communication. Perhaps it was designed to provoke wonder without providing answers. Perhaps the very act of leaving us puzzled was the point. In this sense, the silence is not absence but eloquence. The final mystery, then, is whether we are meant to solve it or simply to learn from the fact that it cannot be solved. Some scientists argue that we must resist temptation, that to project intention or meaning onto an object is dangerous. 3i Atlas, they say, was natural. Strange, yes, but natural. To leap to conclusions about aliens or messages is to fall into the same trap as our ancestors, who saw gods in every storm and demons in every eclipse. The final mystery, they argue, is simply that we lack enough data. If we had better telescopes, if we had a probe nearby, we would know. The mystery is not cosmic, but circumstantial. We missed our chance, and so we are left in ignorance. And yet, even among the cautious, the unease remains. Natural or not, 3i Atlas felt different. Its acceleration mocked our equations. Its surface played tricks with light. Its very survival across interstellar or intergalactic space seemed improbable. It refused to be ordinary, and in refusing, it became extraordinary. The final mystery is not just what it was, but why it insisted on being strange. Why did it leave us with riddles instead of clarity? Why did it come and go without fitting into our categories? Why did it defy us? Perhaps the answer is simple. The universe is stranger than we know. The final mystery may not be 3i Atlas itself, but our expectation that the cosmos should be understandable. We assume that with enough data, enough models, enough equations, everything will make sense. But what if some things do not? What if the universe contains phenomena that cannot be reduced to certainty, that exist precisely to remind us of our ignorance? In that case, 3i Atlas is not a failure of science, but a gift. A reminder that wonder is not obsolete, that mystery still reigns in the night sky. The vanishing point, the outsider problem, the missing twin, the alien sail, all are fragments of the same puzzle. Each offers a piece of the story, but none completes it. The final mystery is the whole itself. that a visitor came, that it refused to be understood, and that it left us changed. We are no longer the same species we were before. We are now a species that has seen an interstellar stranger, a traveler from beyond, and we are left to wrestle with what it means. In the end, perhaps the final mystery is not about Three-Eye Atlas at all. Perhaps it is about us, about how we respond to the unknown, about how we create stories to fill the gaps, whether scientific models or myths of messengers, about how we hunger for meaning, even in silence. Three-Eye Atlas is gone, but the questions it left behind remain. And in those questions lies the measure of our curiosity, our imagination, our humanity. The final mystery is unsolvable, and that may be its purpose. Not every visitor comes to give answers. Some come only to remind us that the universe is vast, that our knowledge is small, and that wonder still has a place in science. Three-Eye Atlas came, dazzled, defied, and vanished. It left us with no certainty, only awe, and perhaps that is enough. For in the end, the final mystery is not that we failed to understand Three Atlas. The final mystery is that it came at all, that across the endless dark, a stranger crossed our path, lingered for a heartbeat of cosmic time, and slipped away, leaving us forever changed by its silence.